We should be live. I hope. Alrighty. Let's see if there's any complaints on this thing. Seems to be good. Good evening, everybody. Happy Friday. Welcome back. Alrighty. We are going to spend some time on OpenXR today. So a little bit different from our usual program, but there's a couple of things that I wanted to look into as far as OpenXR is concerned. I thought it'd be nice to do that on the stream. Before we get there, however, there are two bits of news that we need to start looking at. One is Godot 3.2.4 Beta 5 was released earlier in the week. Yesterday, to be exact. And I want to spend specific attention to... I'm not going to go to the pull request for it. WebXR support for VR games. So, one of our contributors, DS Snowpack, who has also got a really cool YouTube channel where he showcases what he is working on. He's been working on WebXR for the past couple of weeks, months, something like that. And he got it all working and worked together with Fabio, if I'm not mistaken, who did all the HTML stuff for Godot, to get it all working properly and making sure that everything works according to, how Mozilla wanted everything to work. And it's pretty impressive. I haven't played with it myself. I've only been looking at his videos and seeing what he's all done. I just haven't had the time to really try that out. I do want to, because it's very interesting what he's been doing there. But yeah, check it out if you're into WebXR. That is Godot running in a browser with VR support, which is pretty neat. There's a bunch of other really cool things in this release. So yeah, I'm hoping that 3.2.4 will be out of beta soon, because there is a lot of stuff in there that is pretty neat. The other thing, and for that, I might as well actually look in here for that, because I don't know if it's been accepted yet. Let's have a look. Which version is in here? Yes, 3.0.0 has been officially released in the asset library. So this is the latest version of the Oculus mobile plugin. Unfortunately, Gear VR support has been removed from this one because the latest SDK that Oculus has released no longer supports the Gear VR. But this plugin supports the Quest and the Quest 2. Now, for those of you who have seen my video on building the plugin from scratch to enable the latest version, you might remember that there was now the need to do to work through the Android build templates, which complicated things a little bit. This version of the plugin has been changed to still use the older approach. So you can just install a normal Godot. I think 3.2.2 was the minimum that Freddie has said. So you just download, the latest stable version of Godot. You go into the asset library, you download the Oculus Mobile plugin, and you are... Don't touch my boom mic. You're ready to go to develop for the Oculus plugin. Now, the newer approach that we support in the main repository that works through the Android build templates eventually will hit a point where we'll be using functionality that means that we cannot deploy it in this way, and you need to do the extra steps of putting a build template or installing the build templates into your project folder and copying some files in place before the Oculus plugin will work. But right now, the current version that is in the asset library is a special version that allows you to use all the new functionalities, including using it with the Quest 2, using that just the normal way. Download the asset and just go and work with it. So, hi Rodzilla, hope you're doing fine on this Friday. So yeah, that's really the two things that I quickly wanted to touch upon tonight. So the new version of 3.2.4 beta, which contains WebXR support, and the release of the new Oculus Mobile plugin version 3, which properly supports the Quest 2. And yeah, there we go. 3 weeks left before I finally can start working on some of this stuff full time. There's been some really interesting discussions the past couple of days on the Discord channel, on the XR channel, the Godot Discord XR channel, around a bunch of experimentations that some of the other members have done, trying to get the current OpenVR plugin to work under Vulkan. It's quite a lot of work there where they already got pretty close, but it's a bit hacky. But you know, it's still good to do that stuff because it teaches us a lot about the sort of problems that we run into, and that will all help in actually building the correct version and you know, putting XR support into Godot 4, which I am personally looking very much forward to working on and finally implementing. It's something that I've been wanting to get started in for a couple of months, but time has just not permitted it. And now I get to do it full time, which is really cool. I'm really excited about it. So, I think I've mentioned it before, but we, at our current line of thinking, this can always change, but our current line of thinking is to make OpenXR the main implementation that Godot 4 will work. So that will be the first cap of the rank, getting everything to work with OpenXR. Then we're going to start making sure that the GD native linkups to the plugins support Vulkan properly, and then the existing plugins will be brought up to Vulkan as well. Now, we're not sure yet what that means for all the different ecosystems. OpenXR works really well on the Linux and Windows. On the Android side, they're still working on the specs to support it on normal Android devices. Obviously, Oculus has done their own OpenVR or OpenXR runtime for the Quest, so that's something that we're experimenting with. But we have to see how much of that can be done core and how much of that needs to be plugin. But the current line of thinking is to make OpenXR a core module instead of a plugin. Don't pin me down on that. That opinion might change. That all depends on what issues we run into. But that's our current line of thinking. Just making it a first-class citizen, especially because there are plans around the way that the export works in Godot 4. Right now in Godot 3 and earlier versions of Godot, if you wanted to slim down the executable because you didn't want to include features that you weren't using, and especially on mobile, that's obviously very important, you had to build or compile a custom version of Godot. There was just no other way around that. But we're currently looking into whether we can make that part of the export. There's already a project. I don't know what the state of it is, whether it actually has been merged or whether it's still a PR. But there is already a project around doing that functionality for iOS because of the way that iOS works with Xcode, where prominent iOS modules are now actually compiled separately from the engine, and they're linked into the engine at export time because, you know, we're running everything for Xcode anyway, so why not? So that's now on the table, whether we can use that same approach for other platforms as well, so that basically what is basically in your in your templates when you when you look at manage export templates. So when you're installing your templates, the thing that you're installing at that point in time is no longer the end executable into which we inject the projects, but they will be libraries, and there'll be a final compile step once you export. It adds a tiny bit of extra time to the export process, but the result simply is that you get more optimized executables. Now, the other thing that's really nice about that approach is that it becomes easier to add in third-party modules. So things like AppMop and stuff like that. if someone's built it as a module, as long as it's built based on the same version of Godot. In theory, you should be able to compile that as a library, and then it'll. I keep hitting my my boom mic. Sorry about that. Yeah, you'll just link that in on export, and it works. So that's a little bit of a different approach around modules. And again, this is all up in the air, right? There's nothing of this is certain. This is just what's being talked about right now because of the work that's been done so far. I'm really hoping that that will come to fruition, because I think that for VR, that's going to be a major improvement on how we do things. GD Native has served us well, but it is a little rickety. Now, there are also enhancements planned for GD Native, which will make it easier to build GD Native plugins. We'll see which direction we go. But we're really thinking about making OpenXR a first-class citizen. Ryan, well, for me, on the short term, actually, I can go back to the introduction that we gave. It's already gone a bit further down, but basically, I've agreed on a work package together with the Godot guys. My main focus will be on getting OpenXR to work in Godot 4. So right now we're working on the GD Native Godot 3 OpenXR plugin that Christopher did all the groundwork for, and that I'm now involved in as well. We're kind of using that as a testing bed to really get our experience with OpenXR up and make sure that we we try out different options before we start adding something to the core. But the whole idea is to make that all work with Vulkan. Where's my document that I was looking at? But obviously there's a lot of related stuff there. Godot running on Android is going to be very important for support, for instance, for the Quest. But there are other XR devices on the market that are Linux-based. So getting Vulkan to run smooth on Android is going to be a big part of getting VR support. And that is also one of the elements that I'll be focusing on and helping Jean out to make sure that we get that all up and running. So yeah, again, like I said, my main focus will be on the VR parts of the Godot engine, but there's a lot of overlap with other things where I'll be helping out. So it is mostly that I will be working on as far as working for Godot is concerned. Obviously, my personal hope is that because I've been doing all Godot development and everything for this channel in my spare time and have had a full-time job alongside of that full-time job is going to fall away. It's going to be replaced by Godot, which hopefully means that I will have more time. Depending on it. It's not going to be a 9-to-5 job for Godot, of course. It's that's not how open source works. But I'm still hoping that I can dedicate more time to my personal projects as well as a result, because there is a big chunk of my workload falling away, and a lot being moved into development for Godot. But yeah, I want to continue on obviously my tutorials. I'll keep working on the space game. That's really something that I really want to get to a point that is a working game. But I want to tackle a few other things as well, because one of the reasons why I waited so long, because I wanted to build that space game for a long time, but I kept postponing it. And the reason for it is because when you look at it as an VR game, the VR part of it is really simple. It's just being able to look around. The rest of that game is just a standard space game that works exactly the same as a desktop game would work. There's nothing special VR-ish about that project. And obviously, one of the things that I want to do as the person who spearheads VR and AR development on Godot is I want to make sure that there's enough that there are enough example projects out there that someone who wants to do a puzzle game in VR has something to look at. Someone who wants to do a first-person shooter game in VR has something to look at. Someone who wants to, make another Beat Saber has something to look at. Now, obviously, I'm not the only one, luckily, working on those things. Neospark is, for instance, a good example who is making demo projects. He's got his Minecraft-inspired game in VR. He's got his Beat Saber-inspired game in VR. Those are all really good examples that people can look at how that's being built and then use that knowledge for their own projects. But I want to make sure that is a big part of what I do going forward, because I believe that is what is required for more people to get involved in using Godot for VR development. So. Yes. Okay. The HP Reverb G2. I unfortunately don't have access to it. The only way that you can make it work with Godot is if you go through SteamVR. The problem that you have, and I unfortunately played around with it the other day, and I left it on the other side of my green screen, which is a bit dumb, because I've got the Acer MR headset. The big problem that the MR ecosystem has is that Microsoft, in all its wisdom, has decided to only support DirectX. So the whole OpenXR platform is DirectX based for them. Godot is a OpenGL based engine, and Godot 4 is a Vulkan based engine. So there are obviously layers in between. For instance, currently Godot 2 and Godot 3 use this library called the Angle library, which is a library that was officially supported by Microsoft as a compatibility layer between OpenGL and DirectX. It allowed you to run compile OpenGL applications against the compatibility layer that actually your game became a DirectX game. Just you program OpenGL. Pretty neat. But they've kind of abandoned it. And while Google has taken it over because they're using it for Chrome, I think, they don't support all the platforms that the original project supported, including no support for the holographic ecosystem, which is really annoying. However, if you've got Steam VR installed, then Steam is able to use the MR headsets and present them as Steam headsets. And you can play all the Steam games, including if you use the OpenVR drivers for Godot. You should be able to use those. So yeah. All right, that sounds pretty cool, Enchilla. Interestingly enough, I have heard a lot of people who wanted to do visualizations of certain, of various things. Obviously, architectural visualizations is a good example, but product visualizations indeed as well. Happy New Year, Declan. And I think that something like Godot is actually really suitable for something like that. So I hope you succeed in there. I'm looking forward to seeing what you come up with. It's I think it's something that is really suited for. So Ryan, completely agree with that. Vulkan is incredibly intimidating. I'm looking forward to working more with it. I've had some exposure to it so far, looking at some of the stuff that has been built into Godot now. Obviously, I made a start on the Sky Shader support, and then ClayJohn took that over from me and completed it. But it gave me a good first introduction into what it does. I'm going to obviously put that into high gears, because I really need to learn it to get the same level of understanding as I have right now for OpenGL, so I can help John out specifically with the Android stuff that we need to do there. The OpenXR integration for Vulkan, it's painful. but it's not rocket science. It's pretty straightforward. The big problem that we have right now, and the thing that also we ran into in the discussions on Discord, is in OpenGL was really simple. You rendered an image and you ended up with a texture, and you gave that texture to the compositor. With Vulkan, there is far more information that you need to provide, because you're not just giving the textures, you're actually giving you're setting up the render environment in a special way, and you're giving your render context to the compositor so that it can more efficiently render stuff. The other thing that I'm very thankful of, the guys who have already been experimenting with it. One of the things that came to light yesterday, which I wasn't expecting, but at the same time I don't find surprising, in the current implementation with the way that we work with OpenVR, we render the left eye, provide the image to OpenVR, we render the right eye, provide the image. We're actually using the same buffers. We're trying to be efficient with memory and efficient with with resources. So once one eye is finished, we provide the texture, and then we go on to the next one. The Vulkan version doesn't actually render the left eye out to the HMD the moment that we submit it, which the OpenGL one does. Instead, it waits until you then supply the right eye, and then it creates the final image. But because by then we have overwritten the left eye's buffer with the right eye, because we were using them, we suddenly don't have stereo anymore. We have two right-eye images. Now, the nice thing about this, of course, is that the way that the OpenXR library and the Oculus plugin, or the OpenXR plugin and the Oculus plugin work, we don't have that problem to begin with, because there we're actually supplied with with Oculus we're supplied with frame buffers that we need to do. We have to specifically create them according to the demands that Oculus puts on us, and then we provide the render buffers to Godot's render engine and says, don't use your own ones, use these ones. And OpenXR works in a similar fashion, where we are creating the render buffers in the plugin and providing them to the render engine, saying render into this buffer, and then we display the buffer. So obviously, that's probably going to be the same approach that we're going to take with Vulkan as well, where we're going to have more control from the XR interface, and having the XR interface to create or maintain the buffers. It might still go back to the render engine to request the buffers. We're not sure yet. But then render the two eyes to two separate buffers, commit the two buffers to the compositor, and then the compositor is going to do the final render to the HMD. And hopefully it'll work and be a lot faster than it is today. Victor, well, glad for another VR developer in our midst. Very cool. Hope you'll eventually be able to show off some of your work. That would be really nice. Can we upgrade the teleport example so that we can stick up and then left, right? Okay, the current one is that you use the trigger to initiate the teleport, but you can use your thumbstick to rotate before you you release and get there. And the reason that was the approach that I took when I wrote that was that in the beginning, the first controllers that were around were the Vive ones, and the Vive ones don't actually have a joystick on them. They only have the little slider touchpad thingy on the top. It's like the little D-pad, I guess. I can't remember. I haven't touched. I haven't had a Vive one in my hands for a long time. So yeah, that is why we did that approach there. But it shouldn't be hard to change that, actually. So we could have a look at that eventually, or look at. I think it's about time to do a version 2.0 of the teleport function anyway, because I think that's one of the very first things that I created for my toolkit. So we might give that some attention at some point. Now, that whole story, the whole the Vive wand controllers have very different feature set from, you know, for instance, these guys, the touch controllers. I'm right now dusted off my my beautiful Oculus Rift. That's the one that we're going to use tonight instead of my my Index, because I've been testing everything on OpenXR out with the Index, and I actually wanted to see how the Rift performs, and see actually if we can get the OpenXR runtime for Oculus going, which I haven't played around with yet at all either. So that's something that we need to have a look at. But this is a really important part of the changes that are coming. And I can actually quickly go and have a look at that. Godot VR, OpenVR. So, and actually I want to go into the assets, because I wrote a little bit of documentation here, and I wrote documentation about OpenVR actions, which are actually in the current version. I still need to upload the asset at some point, but there's still one or two little fixes that I want to do before I do that. But in the current master, this is all working. Now, what is so special about actions? And it's actually a good starting point to look at OpenVR, because OpenVR went a step further than OpenXR did. OpenXR is leaving more to us to solve, while OpenVR moved a lot of logic into SteamVR itself, which you kind of get, because it, you know, makes it easier to for users to set things up the way that they want. But at the same time, I believe that some of this logic really belongs in the game engine itself, and not in the support layer. In which case, you know, I've only touched the surface on how OpenXR expects us to do this. But the bottom line is, this is the thing that they came up with to deal with all the differences between these controllers. Now, the odd one out is Oculus at this point in time, because obviously Oculus only has the touch controllers. So the touch controllers for the Rift S, the original touch controllers for the original Rift, the ones for the Quest and the Quest 2, they're all slightly different devices in how they operate and how they work. But as far as the interaction is concerned, they're all the same. So in their SDK, the controllers are completely hard-coded. You know that you only have two controllers. You have one for the left, you have one for the right. Each one has two buttons, a joystick, a trigger, and a side grip. And that's it. So for Oculus, you're basically 100% ensured that you have what you have, which also locks them down, which is kind of the problem that you know, you get your touch controllers and that's it. Now with SteamVR, obviously, first of all, we have the fact that SteamVR supports all different HMDs. So you can use SteamVR with a original Vive, with original Vive ones. You can use it with a Rift. You can use it with an Index, with the new Index controllers. You can use it with MR headsets and the MR controllers, which are the really unique ones out, because they both have a joystick and a trackpad, which is one of the really annoying things, because people who develop their games for the Vive want the MR controllers to have the trackpad as their primary interface, because that matches with the Vive controller. And people who write games for Oculus, they're used to having the little joystick there. So when they want to use MR headsets, or also support MR headsets, they want to use the little joystick as their primary one. Godot, I think, uses the joysticks as primary, which is probably because I started with with the Oculus ecosystem. I never had a Vive, unfortunately. I did use it at the beginning, a friend's Vive, but I've never had my own. And this whole system is meant to deal with that, where we're basically saying we're going to actually make the game engine completely unaware of what the controller looks like and what the controller can do. So instead of saying, hey, I'm going to program my teleport to work with the joystick, I'm instead going to say, I have a teleport action. And the teleport action has two parameters. Is initiate the teleport and rotate your teleport. So you define those two actions and say, I want those two actions in my game. That's what I need to support my teleport. And then you go into the bindings configuration, and you're going to say for each controller that you support, what controller input maps to that action. So on a Vive one, you might still stick with the old approach and say, you know what, the trigger is going to initiate my teleport, and I might not even allow rotation because I don't have, something to do that with, or I'm already using my trackpad for something else. While for my touch controller, I'll map it to my little joystick. And I'll say, joystick forward is my initiate teleport action, and moving it left and right is rotate the teleport. So that's what the whole action system is about. And we're going to have a bit of a deep dive into how that's solved in OpenVR. And then we're going to have a look at the XR specifications and see what the XR specifications say about how OpenXR wants us to do things. And then we're going to have a look at our plugin, because our plugin currently has everything hard-coded. We're going to see if we can get some sort of mapping system going, so that we can make a start to how we want to implement that. And we probably won't get through the whole thing by the end of the day, but or the end of the stream. Let's just see how far we're going. Just to work on a Quest 2. William, you mean OpenXR or you mean Godot? Because Godot already works on a Quest 2. You just need to download the... have I still got it open? I still have it open. Download the Oculus mobile plugin and you're ready to go for the Quest. I think NeoSparks probably hasn't updated his toolkit yet with this new version of the plugin. I do think that he's about to do that. But even with this one, it uses the previous one. It will still work on a Quest 2, but it will just be in Quest 1 mode, basically. So you don't have access to the higher resolution and you don't have access to the higher frame rate. But you can get started with it. The nice thing about the toolkit, because as far as I'm aware, the toolkit includes the plugin. Don't hold that against me if I got that wrong, but I do think it does. The toolkit gives you a whole bunch of classes that you can immediately hit the ground running with. So he has teleport function as well. He's got a movement function. He's got all the hand interaction stuff in there. He's got the pick up stuff and manipulation stuff in there. It's a pretty cool toolkit. If you only developing for the Quest, I can 100% recommend starting out with NeoSparks work. If you are building something where you want to be cross-platform, you want to deploy your game on a Quest and on desktop, you can still use NeoSparks things, but there are a couple of Quest-only features in there that you might want to not touch. Or alternatively, you can have a look at GitHub. VR. What's the thing called? Where are you? XR tools. So I have my library that I've been building, which contains a whole bunch of helper objects that are cross-platform, that don't assume anything about your platform that you're implementing. Yeah, I still haven't actually played with the G2, which is a real shame. I wish I knew someone who had one. It's always the downside of being in Australia, that the VR community isn't that big here. Bigger than I realized, but with the pandemics, there are no more meetups and stuff like that. So I'm falling behind a little bit on what's happening here in Australia. But yeah, I've seen the pictures of the controllers, and I was very happy to see them, because the controllers within the MR ecosystem has always been the part that's been a letdown. So to hear that the G2 controllers are closer to what the touch controllers offer is welcome news. So well done, HP. So far, everything that I've heard is very impressive. It does seem like HP has got a really good headset in their hands. So yeah, looking forward to trying it. Yeah, Ryan, exactly. That's the whole point around the action system now. There are parts of the action system that I find a little cumbersome. One of the nice things about the old approach And in Godot, we already tried to unify some of these features to make all the controllers of different vendors work as similar as possible, so they are as interchangeable as possible. The nice thing about it is that it's very reactive to what's happening. So when you, especially under the Vive ecosystem, slash the Valve ecosystem. So when you look at the Vives and you look at the indexes, they were always designed to not limit yourself to having the two controllers, the left-hand controller and the right-hand controller. You've got the pucks that you can track. You've got peripherals that you can track. So you have actually got gun peripherals that you can track, because they can track basically as many trackers as they want, because of the lighthouses. The lighthouses send out a laser grid, and it is actually, I don't have my Knuckles controller here. No, I do have one. Well, if I can reach it. Sorry. So, Knuckles controller. So the Knuckles controller works very different from these guys. So these guys, I can't show this on my camera, unfortunately, but these guys have a ring of LED lights, right? So there's lots of little infrared lights hidden inside of this, which are picked up by the cameras. And that is what is tracking. So the cameras on the Rift, inside out tracking, they're tracking the controller. It's designed to track two controllers, a left-hand controller and a right-hand controller. They each have a different pattern of lights. That's how it can recognize which one's which, and it works. So you have a left-hand controller, you have a right-hand controller. That's it. I was talking to Thetan the other day, who is doing all the OpenHMD implementations for the inside-out tracking on the Oculus ecosystem, and he was telling me about how that system has a maximum ability to track these devices, and you're basically stuck to those two devices. You can't introduce a third. While with these guys, because you just have the laser grid is hitting sensors on the device and doing some nice little triangulation magic. I don't pretend to know exactly how it works. This device figures out what its orientation is based on the two lighthouses, and then over Bluetooth communicates with the headset saying, I'm here in this location. In theory, because each one is just using the laser grid to figure out where it is, as long as it's not being obscured by another tracker, it can figure out where it is. So you can have your two Knuckles, you can have trackers on your legs so that you can track the position of your legs. You can have, like I said, trackers on peripherals so that I can pick up a gun if I want to do, a real gun prop if I want to use that, which is what they do in the, the big VR halls and stuff like that, where you can play proper VR, VR games in a big hall and run around like crazy. It's a different kettle of fish. And the thing is that when you look at the old system, that was actually really well geared to having an unknown number of trackers and controllers that you would potentially want to bring into your game. While when you look at the action system, you're actually designing it specifically. And while this interface in OpenVR is really cool because it automatically detects what you have. So in this case, I just have my Knuckles controllers on, and I just if I plug in a gamepad, all of a sudden, when I go into the bindings, I see the gamepad as well. If I have a puck tracker, all of a sudden, I see a puck. And the idea is that you define bindings for every device that you want to use. But each binding is therefore unique. So you're identifying your left-hand controller, you're identifying your left knee puck, you're identifying your right knee puck, and they're all very precise mappings. And one of the things that I found really difficult there is, for instance, think of a trigger, right? So I define an action fire, and now I link the action fire to my right trigger, and now I can fire a gun with my right trigger. Now my player is left-handed, picks up the gun with the left hand, and still has the fire bound to its right trigger. Now, obviously, you can bind both triggers and then put some logic in your game and say, well, hey, yes, I'm going to react to that action, but only if I'm actually holding the gun in that hand. But yeah, there are some interesting challenges in how you define those mappings in order to make them work for you. It's more precise, it's more defined, but it's a trade-off. It's a little bit more complexity, but as a result, you can make your game work with not just the controllers that you own and that you know about, but in theory with any future controller that might come out. Because all you need to do, if someone comes out with a new controller or a new HMD, there's a new player on the market, as long as they support, and in this case SteamVR, you just need to add a mappings file for their setup, and all of a sudden your game works with their controllers. Yeah, Beep Saber. So obviously there are two. Well, there are more than two, but the two that I obviously know out of the top of my head are my own. So if you look at my GitHub page and you browse through the repositories, you'll have all the sample projects like my vehicle demo. You'll have my physics tutorial here. Now, this is not VR based. All right, yeah. So the object interaction VR, that's a VR project. So there's a bunch of projects in here that are all, based on my tutorials that are on my YouTube. The other one, highly recommend, is Neospark, who has then his Oculus Quest toolkit, but he also has the Beep Saber project, Voxel Quest. So that's a Minecraft in VR that he created. That's a Beat Saber clone that he created. So he's got some really cool sample projects. He does everything with the Quest, so all his sample projects are all geared at using the Quest, and they all use his toolkit. So obviously, that's something to keep in mind. But yeah, there's some really cool things. This is a really fun plugin to play around with, using Google Seurat to create really impressive scenes with very low resource usage, which is pretty cool. So yeah, those are the two that I can then think of the top of my head that have open sourced their project. Now there's a couple of guys on the Godot Discord XR channel that are working on different projects. So there's Michael, who's working on a VR workout game. I believe that one's open source as well, but that's a really impressive. So he's doing a well, I wouldn't compare it to Box VR because it's in a similar line of this similar area of games, the fitness games. So working out on a rhythm, but he's really targeting more movement, not just boxing with your hands. You're actually moving your whole body to score points through his game. It's quite impressive little thing. I watch his updates on his YouTube channel. It's really impressive what he's doing. But there's a couple of other guys who are working on projects as well that I believe are open source, but should really get a register going at some point in time. Alrighty. So I need to drink some. So one of the things that I was looking at, let's go back through here. So this is my my really boring little test projects in the OpenXR plugin. I really need to make a better one. I might do that on the stream one of these days and just dress this up a little bit more. Is it actually... That's still using VR Common. That's actually something we need to change as well. We need to change that over to using Godot XR Tools. VR Common is the old name of Godot XR Tools. It's the same library, but it's a much older one. So I might end up updating that in a minute, because we'll probably end up using that today. So, actually, let's go through this a little bit more, because it's actually having a good look at how this is set up and how this is working is a pretty good idea. So, even though we're going to be looking at OpenXR today, having a look at, and I just want to close this all off, even though we're going to be working with all this stuff today. There we go. let's just have a quick look at what's behind this. So in our OpenVR projects, we can find a demo project in here. Inside there is our standard OpenVR add-ons. And in there, there's a default action binding set of files. And the bindings are basically divided into two things: an actions JSON, which names all the actions that we want to support, and then binding files for each controller set that we want to support. And obviously that would start expanding if there's more vendors that we want to start supporting. But even if we don't support a vendor, the user themselves is able to put in the mappings based on your actions, because your action files, that's how you tell OpenVR, these are the actions that I want to have filled in. Now, the default actions files is a compatibility layer file. So basically, just about all the mappings are standardized here, and this will make the controllers mimic the old approach. So all of a sudden, if you are using your standard AR/VR controller nodes, then all the button inputs that are in there. So we have button pressed and release signals, and there are, let's actually go and find that on our help. We have our get joystick access values method. They will access those standard bindings, and those features will therefore only work if you keep the standard bindings intact. But if you don't want to use that, if you want to use the new approach, which is probably, in Godot 4, I'm planning to break the way that the AR VR controller works right now, because I want it to be much closer to the action-based approach. So instead of it working through, instead of it sending, button 1, button 2, button 3 is pressed, you're going to get signals like this action has been triggered on this controller. That's the direction that we're going to be taking with that. But today, that's the old way of working. And in the plugins for OpenVR, and I'm going to be doing the same thing with OpenXR, there are these new classes that use the new approach. And eventually those classes will merge into the AR/VR controller nodes, or we might even introduce some new nodes there. So these action files are just to use the new action system to mimic the old approach that we have. Now, instead of editing these, because you really want to leave the add-on alone, because if there's a new version of the add-on, you just want to be able to replace the old add-on with the new add-on. Now, if you do that and you've edited these files, you would lose your changes. So what we've done is we've made it possible to create an actions folder in the root of your project, and in there you place your action files. If you don't create that folder, it will use the default action files. If you do create that folder, those action files will be used for your project. And you can see that those are a little bit different. There's some different entries in there because I've been experimenting around with making things work. So again, I just want to give a bit of an overview of how the OpenVR plugin does this, because we then need to start looking at, okay, how are we going to do this on the OpenXR side? I just want to make that comparison before we start designing anything. So once you've defined that action file, and therefore you tell OpenVR all the actions that we want to support, and the actions you need to think of in a very broad sense, because it's not just actions as in, hey, I've got a trigger that's being pulled. It's also your mappings of joystick inputs, and also it is the mapping of positions. It's a mapping of the skeletal input if you want to animate your fingers. So that's all in there. They're all controlled through those same files. So you can see in the action bindings here, we just have a listing of which controller mappings we have. So that just points to the different files that we have here, and that list will grow as you support more platforms. But then we have actions here where we say, well, we've got a trigger action, and the requirement is that it's suggested, so we don't have to map it, but we would prefer you to map it. I think they're all suggested here for some reason. I would have thought that a couple of... So optional, what's the difference between suggested and optional? Maybe suggested is the one where you have to actually specify it. Or I think if you leave that one, you get like a warning. If you leave that one empty, it doesn't care. I think there's another option where it says, hey, if you don't set this one up, then you can't save your mapping. So you have to do that. So these are all inputs, but you can see that there are different types of inputs. So a vector 1 is like a trigger, an analog trigger. A vector 2 is a joystick input. A Boolean is a button. And then we have a pose. So this is one of the things where old clashes with new as well. In the old system, we tracked the controller. The controller had a position in space, and that's it. But in a new approach, and I believe we've got a nice little diagram here, courtesy of one of our friends. Here we go. In the new controller, we have 1, 2, 3, 4, 5 different positions that are being recognized. And that is because the dimensions of all these controllers are different, right? This one's way bigger than this one. So the position where certain things are is very different. So where your grip is in a different place, and where your trigger point is in a different place. Now, what's really interesting is the little white ball here is actually the position that was tracked in the old system. So you can already see the problem here is if I put my mesh where my ball is, my mesh is actually not going to be in its real position. Or if I'm smart enough and actually position the mesh properly, then if I grab a pistol or weapon and I place it there, it's going to be in the wrong place. Now, in a lot of my demos, I grab my controller and I place the pistol or whatever, and I then move it into a spot so that I get a offset from that place. But that then, it's only correct for that one controller. If I have a different controller, I actually need to have a different offset. So that is one of the reasons why they introduced these additional tracking points. And in this case, that grip button would be a much better place to orient your pistol with if you grab a pistol. This yellow one, which is the tip of the controller, the tip nose, will be the position, the tracker on which you would, for instance, child a laser pointer. So our laser pointer feature that we introduced should be linked to that, and that means that it will always, point a natural way because the vendor of the controller will have placed that in a way that makes sense. So yeah, these two are just two different versions of the raw. So that's the raw position in the new approach. That's the raw position in the old approach. So that's why those two are always in the same place. The black one is the base, so the bottom point of our controller. So you got a couple of tracking points there. So now you have one controller with multiple locations that we are tracking, which is not possible with the old system. So we introduced this new type, the OpenVR pose, that then binds to a pose action, and that is now tracking that location. And I actually created that pose object in OpenXR already. I've renamed this thing, but this is my no, that's my OpenXR GDS script. I thought I did a pose there as well. Maybe I just called it hand there because I just started with left and right hand, because that should have been my pose object actually. Might have, not sure why I changed that, but I might end up changing the way that it works. But you can see that these are working outside of our original left and right hand controller nodes. So I'm completely bypassing AR/VR controller here, and I'm actually, working with those locations. And like I said before, eventually this will be merged back into how the controllers work. And instead of the controller identifying a singular controller and saying this is my one controller, this is my two controller, it's actually going to be linked to a pose. And again, right now with OpenXR, we've hard coded a whole bunch of things, and we need to unlock that. We need to actually make that settable and configurable. So we have our poses to deal with. You can see that the actions are used for haptic feedback. So this is, instead of getting input, this is output. You can also see that in this case, we go input, output. So again, this is the OpenVR way of doing haptics now. So the old way was on the AR/VR controller. You could just give a single haptic pulse. Again, this came from the beginning days when we only had the Vive controllers, the Vive ones, which just had a single vibrator, and that was our only out. So we needed to have something better in our haptic system here. There's more poses. I'm just having a look. Oh yeah, and the last version is our skeleton type. And this is the way that OpenVR allows us to get skeleton input, which is, so that we can animate our hand. In the case of SteamVR, when you're using index controllers and stuff like that, it is basing your hand or your fingers positions on a combination of the capacitive sensors of your controller. So there's like sensors in here that sense the touch of your fingers, and it approximates your hand positions. It does a relatively good job. The nice thing, of course, is the touch controllers do the same thing, but the touch controllers only support 3-finger tracking, and these track all 5 fingers, but it's still an approximation. Now, if you use something like Elite Motion, which has both OpenVR drivers and they have OpenXR drivers as well nowadays, because of the whole Northstar ecosystem, then obviously this is actually giving you a proper skeleton that is giving real positions of your fingers. But you can animate a nice little hand thing in there. It's pretty cool. This is all working already in the OpenXR plugin. I'm just waiting on a go-ahead to actually release some models for that, because we've got some nice hand models, some meshes coming that we hopefully will be allowed to add into the plugin, and you can just drop them in. So right now, as you can see in the plugin, we have beautiful mesh-based things, and they look really ugly in here until you... I can actually quickly demo that. That's pretty cool. Pretty happy that I got that to work. So come on, start tracking, buddy. There we go. So as you can see, oops, that actually now looks like a hand. And as I'm moving stuff, you can see that it is moving the bones as well. It's not doing a super job at it for some reason. I'm not sure why. Mind you, my battery is a bit low on that controller, so that might be why. But yeah, that is the mesh-based version of it. But there's also a skeleton-based version where we're actually manipulating the bones of a skeleton. So that you can do proper bone deform of a mesh. And like I said, right now I can't demo that because I can't use the meshes yet. I don't have permission for that yet. But once the meshes are publicly released, we can have a show and tell of that. The functionality is already and works perfectly, which is really cool. So that's already implemented. But again, like I said, it's all hard-coded right now in the OpenXR run instead of making it flexible. Still, you only have a left hand and a right. Hopefully there aren't any... Well, there might be someone who's got a third hand. I don't know. But generally speaking, people only have 2 hands. So it is something that most of these architectures now pretty much assume that you only have those 2. So you see that a lot of the action bindings are like that. So the other thing which is really important is that all these actions here, those are the actions as we name it. So we're defining here, we want a left hand pose, and we want to have a haptic out, and we want to have a button AX input. So that's what we are defining. That's what we are naming. We can use completely arbitrary names here. There is a format to it, so you can't stray away from this 4-pronged format: actions, your application name, or your action set name, I should say, whether it's in or out, and then the name that you've given your your action. But it is then in the mappings where you're saying, okay, I'm mapping the action as I've defined it in my game to an actual input of my device. Now, what these values are is all controlled by whoever provides the the hardware drivers. So they will be different depending on whether it is an index controller or whether it is a Oculus touch controller or whether it is a Vive wand or any of the other ones. Obviously, they've tried to standardize that as much as possible, but they are different. Okay. So again, with all these new objects, we have those bindings in there. So in this thing, I just go through, okay, how do haptics work? So you can see that there is a OpenVR haptic script for that allows us to control the haptics. There is an OpenVR controller that I'm working on, but I had some problems with. The problem that I had is that whenever you define a GD native script, you can no longer create an extended script in GGScript. And because on the controller you often want to have customized logic in your game, that clashed with each other. So, but I do think that is going to become a blueprint for how we're going to modify the XR controller in Godot 4. So here's our skeleton implementation in OpenVR, which allows us to deform a hand mesh. So that's in OpenVR, that's all working. And like I said, I've also got that working in OpenXR now. And then we have the concept of action sets. And that's something that I haven't really tested out properly yet. So I don't even know how well that works at this point in time. But this is the idea that you can have different sets of actions that you can enable or disable depending on your scenario. So for instance, if you have a, let's say that you make a VR version of a GTA-like game where you can walk around the city and you can then get into a car and now you can drive the car, right? So when you're walking around the city, you have an action set that, you want to have your joystick control your character movement. So obviously you have your physical movement around your room, but that's not big enough to move around the city. So you would have your direct motion in there. But the moment that you get into a car, you don't want that functionality anymore. You want to disable the joystick input for moving your character around, and you want to enable an action set that maps your controller inputs to some sort of drive input. So, push the joystick forward, you push down the gas, that sort of stuff. So that is where action sets come in. And I think this is outdated because I think iFire did a bunch of work on this to make multiple action sets active at any given time. So this is definitely one of those things where there is more work to be done, I think. Anyway, that's a really brief. We've only spent an hour so far. That is a really brief overview of how we have done things in the OpenVR plugin. And again, one of the things that I really want to stress is a lot of these I've implemented as extra GD native objects because the core is still using the older approach that that everybody started with, 3 years ago, 4 years ago, 5 years ago. I don't know how long ago was it that SteamVR and the Oculus Rift really hit the market. With the limited capabilities at that point in time, they hadn't planned on these things yet. So obviously, support for this sort of stuff needs to be added to the core. I wanted to do that in this form first, so that we can get that experience, so we can get that environment to try with. And I also hope to get more feedback on how this works, if other people actually understand how this is set up, how to use the OpenVR actions efficiently, see what shortcomings we have, because this is going to become, together with the work that we're now going to do in OpenXR, that's going to become the blueprint of deciding how are we going to change the controller functionality in the core of Godot, because we really want to make it so that instead of you needing different implementations for OpenXR and OpenVR and Oculus, is that we have a singular implementation in the Godot core, where the plugins or the XR interface is responsible for mapping that to whatever the platform supports. Where for OpenVR and OpenXR, it will actually be mapping to their internal action systems. But for instance, for the Oculus ecosystem, if we keep using the Oculus SDK for the Quest and the Oculus SDK for the Rift, which doesn't do this but has all the controllers hard-coded because that's their ecosystem. They have that level of control over their ecosystem. They don't have to worry about other vendors creating controllers for their ecosystem. You have the touch controls, end of story. We'll have to have some sort of compatibility layer there. So that is so which controller is connected when you look at the AR VR controller in general? So again, when you look at the new approach with the action system, the whole point of the action system is that you no longer care. The action system, you say, I need a left controller and I need a right controller, and what that really is, I don't care. OpenVR, you figure it out by mapping my left controller to whatever the user is using as their left controller, and my controller to whatever is in the right controller. Now, with the old approach, with the old AR/VR controllers, we just have a controller ID, and the original implementation was so that it was first come, first serve. But eventually, when the touch controllers came out, there was support added that it would come back and say, hey, I'm the left-hand controller, and hey, I'm the right-hand controller. And we changed the system so that if that happens, the left-hand controller is always controller ID 1, and the right-hand controller is always controller ID 2. And any additional tracker that became active just became, first come, first serve. The Vive 1s were the troublesome exception, because the Vive 1s don't actually tell you whether it is left hand and right hand, while if you use the action mappings, it does. So, because now I've said I have a left-hand controller, I have a right-hand controller, and the OpenVR bindings will actually bind a Vive 1 as the left-hand Vive 1, and it will always be that controller that is the left-hand Vive 1, and the right-hand Vive 1 being the right-hand Vive 1. Now, again, with the old approach, you do have the ability, if we go to our help here, we do have the ability to get the controller name of the controller that is there. Oops. Don't jump around. I just wanted to highlight it. And we've got the hand value that we get back. So, undefined 1 or 2, 1 for left, 2 for right. So that's basically just returning whatever OpenVR returns, or, it's hard-coded in, I think, the other plugins. Yeah, just getting to get a name back, and a name does, in the case of a Vive controller, it will come back. This is a Vive 1.5 or something like that. I think version 5 was the latest standard Vive 1 that you have. But it doesn't identify whether it's on the left or right, because there is no left Vive 1, there is no right Vive 1, it doesn't exist. That's the problem with the old approach. It just didn't exist. And then again, with the new approach, it still doesn't exist, but it maps the hardware ID of the controller to, whatever your bindings are. And thank you for coming. It suddenly fixes, a left hand and a right hand controller. So there's some mismatch here. And also, the problem that we're dealing with, and this is something that I actually want to change in the way that the plugin works. I really want to let go of the old API for a big deal, because it's basically being deprecated. The old way of tracking is being removed from OpenVR. And again, with OpenXR, we have a clean slate, because OpenXR doesn't even have the old approach. It just only has the new approach. And with OpenXR, you have a left-hand controller and you have a right-hand controller. And it really doesn't care that Vive 1s don't have any difference between left and right. It just demands that the drivers nominate a left hand and a right hand controller. So yeah, there is a bit of a transition period. My advice, if you're having troubles around that, is let go of the old approach. for until we in Godot 4 we add this logic into the core system. Just don't use AR VR controller. Use a combination of OpenVR pose for the location of your hand and OpenVR action to capture actions. And again, that's a way that you get joystick input, and then your left hand will always be your left hand, your right hand will always be your right hand. So, and again, the whole point is not to care what controller you actually have, because that's the whole point of the action system, is that you as a game designer, you don't care anymore. You don't care whether they have a Vive wand or an Index Knuckles controller or an Oculus Touch. All you care about is that you've defined that you've got a left-hand controller that has certain actions that it needs to be able to do. That's the beauty of this approach. But again, I can't stress enough the objects that I've introduced in the OpenVR plugin are basically because we don't have the core functionality in place. And with Godot 4, that is a huge part of what I am going to be working on the next couple of months, is to actually build an action system into Godot itself, or augment, because Godot already has an action system, right? So when you go to project settings and you go to input map, either we're going to add VR actions into here, where XR input actions are going to be mapped to Godot actions, and you actually get action signals, and you can use them exactly the same as you're used to using actions as defined here. Or there might be, the need to have a specialized OpenXR action map. I'm not sure. It might be a combination, because again, this doesn't support poses or skeletons or anything like that. So that's still up in the air, but it is something that we really want to make part of the core, and we'll eventually see some of these replaced by core components. And OpenVR Action, OpenVR Pose, and OpenVR Hectic will probably all be rolled into the new XR controller. At least that's my plan. That's my line of thinking right now. Hi, Ivan. Hi, Dragio. Right. Let me catch up on chat, because I think I've missed maybe one or two. I don't know. Hopefully I didn't miss anybody in the chat. Okay. So we have 2 pages open here around OpenXR. The first is the OpenXR specification document, which I don't really think we're going to be doing a whole lot with. We might actually... That's all for our general system, because I think that is already all working. Really? All right, that's interesting. So they've got all sorts of generic paths, but then we have _user, we have reserved paths for our hand left, hand right, our head, gamepad, treadmill, even though I don't think there are many treadmill things yet. Maybe like the Cat V and Omni. That'd be interesting. So they've got a bunch of paths predefined that are hard-coded. And again, this is one of the things that I find really interesting around both the action system of OpenVR and the action system in OpenXR, is it's really targeted at a single user setup. The idea of a single computer controlling multiple HMDs of multiple players doesn't seem to be a thing. And while I know that the option in Steam VR exists to do multiplayer games where a single computer is controlling up to 4 or 5 HMDs, I don't really want to know how much GPU power is required to actually do that. So I can kind of understand that they've let that go, and they've sort of went like, you know what? If you have a multiplayer environment where you want multiple people to work in the same environment, okay, you could have a tracking volume, especially with the lighthouses. You can get there's like warehouse-sized tracking setups that they do with the lighthouses, just controlling, getting a whole network of these things up, and you suddenly have team-based players. You might even have 16 people running around with headsets on. That's only something that you can really do in that way, I think. But the idea obviously is that everybody has their personal little computer in their backpack, controlling just their instance, and then network together, and that's how you do your multiplayer thing. And I think that's why when you look at OpenXR, it's all targeted at single user. There's one headset, one set of controllers, and potentially a bunch of additional tracked things. And that's actually something that's interesting, is that there's no additional tracking things in here. So, and again, because the paths are, these are the reserve paths, so this is a bare minimum support, at left hand, right hand, head, gamepad, treadmill, that you can have a /user puck 1, puck 2, puck 3, or pucks and then 1, 2, 3, or whatever. I'm pretty sure that that's all in the hands of whoever writes the driver software for that. Because again, this is the driver providing values for these paths, and we're just consuming them. And that's I think the big difference between OpenXR and OpenVR actions. In OpenVR actions, we have those paths. So these are basically user hand left pose raw would be exactly the same. User hand left pose raw would be a potential path in OpenXR. In OpenVR, that's hidden to us. We've defined this action, and then in SteamVR itself, the user can map that to whatever input their particular device has, and we've just created a bunch of default mappings, because that's what these are. These are default mappings. They can stray away from that. We might have a default mapping that assumes that someone's right-handed. Well, a left-handed person goes like, "You're stupid. Why aren't you supporting me?" Well, you know what? I'm just going to edit this file, and then going to flip it around, and I'm going to make sure that everything that's on my right hand is now on my left hand, and everything on my left hand is now on my right hand. Hey, all of a sudden, I've changed your game to be a left-handed game. That's the beauty of that approach. Now, with OpenXR, we're actually mapping this, and therefore, that mapping is actually something that we need to do in-game, which personally, I think is better. I much rather have this somehow coming in from my controllers and being able to do that mapping in game. Does mean that I need to be able to have different mapping profiles. That I need to be able in OpenXR. I'm going to be responsible as the implementer to allow me to define mappings for different controller types. So we'll see how far we can get with that today. So yeah, you can see there's a whole bunch of standard identifiers on the inputs. So trackpad for trackpad, thumbstick, joystick, trigger, throttle, trackball, pedal, D-pads, diamonds. Oh, look at that! All sorts of. So they've sort of predefined what possible values should be possible there. Same with the poses. So you got your grip pose, which is the should be the palm of your hand basically. Oh, and aim. Oh, they've only got 2 ones. So an aim pose and a grip pose. That's interesting. Oh, and they got the rest are then as locations. So left, right, upper, lower. Right. That'll be interesting to eventually map out on a controller and see where they actually are. And then standard actions, click, touch, force value. Those. All right, pretty cool. and then our outputs for our haptics. So again, like I said, these paths are the same as the paths that OpenVR has on this. It's just that we are responsible for doing the actual mapping, which is again interesting because if we only go that far, and we implement that mapping inside of Godot as something that we can do, we don't really need SteamVR's mapping anymore, and that's kind of going to clash. So it's going to be interesting to figure out what we're going to do there. Or, we actually define these actions inside of our input map. And then we have a new tab here where we can map those to the actual input paths of the different controllers, where we can say, hey, this is the mapping for this controller, this is the mapping for this controller, this is the mapping for this controller. And in the situation when we're in SteamVR, that tab will simply be blank or unused or ignored because you have that now on the SteamVR side. So plenty of room for thought. Are you coming to the virtual GodotCon? I'm planning to. My main problem is that I'm in Australia, and a lot of the stuff are when I'm very much asleep. And while I'm planning to adjust my my biological clock, so to speak, once I start working for Godot from the 1st of February, I'm going to be more flexible for saying, well, I'm going to sleep part of the day because my kids are at school anyway and my wife is at work. Right now, I still have a day job, so it'll be tough. But I am planning on attending a number of the virtual GodotCon sessions, and I'm not quite sure which things are doing. Snowback, how you going? I haven't checked the direction yet. We haven't gotten that far yet. Did tell everybody about your WebXR being now available in the beta 5. Told everybody to go and check that out. Right now, the first hour of our session, I have basically given an overview of how the action mapping works in OpenVR, because I'm now looking at the action mapping in OpenXR so that we can start actually implementing the joystick logic. And I kind of want to get to a point today that we know how the inputs work, and maybe either through a file or maybe for now it's still hard coded. We're going to make sure that some of these inputs are properly mapped, so that we can actually get some values of our joysticks. But my end goal is creating my end goal is creating a mapping system in the current plugin for 3 to actually get something working. So that's my goal for now, because I really want to get that up and running before I'm actually going to do anything on Godot 4, because like I said, I want to take the lessons learned from this and the lessons learned from the OpenVR action system and use that together with the input that I'm hopefully going to get from people who are actually using this stuff to say, okay, how are we going to now design the core implementation? How are we going to change our XR controller to actually do this? How are we going to do the mapping setup in Godot itself? Because we want that to be cross-platform. And yeah, giving OpenXR priority, I think, over that. And that's the other thing, right? How far do we want to go? Like, one of the problems that I just sketched out is OpenVR does all the mappings in SteamVR. We define which actions we want. And then in the SteamVR environment, we map that to the actual controller inputs. While OpenXR says, here is a methodology for defining our actual hardware paths, the paths that identify the inputs on our controllers. Game engine, you're now responsible for creating a mapping system that maps that to your actions so that you have something that is controller agnostic and that your game now suddenly works with different controllers. And that means that for OpenXR, we need to create that mapping interface in Godot, which means that if we do that and we make that a core feature, then for OpenVR, that's going to be double We now have mappings in Godot and then mappings in SteamVR. So that's the first thing that we're going to need to deal with. And what I'm really interested to see is once we get OpenXR working in this way, what does that do with SteamVR? Does it disable the mappings of SteamVR? That's something that I'm actually hoping for. With Oculus, where we don't have this at all, that's easy. We can name paths for every input in the Oculus plugin and make the Oculus plugin behave as if it has input mapping. Because basically we're doing what the drivers right now are doing in OpenXR. And that is assuming that we are going to use the Oculus SDK and just have a Oculus SDK plugin, which, for both OpenVR and the Oculus plugin, at some point there's the big question mark. Because if OpenXR remains on its current trajectory, it is going to supersede the SDKs. Both Oculus and Valve have put their might behind OpenXR. So there is a good chance that in a year or two, we will see those interfaces, those SDKs, getting deprecated. Now, again, that will only happen if OpenXR adoption happens. But I'm betting that it will. Seeing how well the OpenXR specification has been thought out, how well it really takes the best of all the three major platforms, Windows MR, Oculus, and Valve. It really took the best of all those platforms and said, okay, let's take the lessons learned of these three platforms. And logical, right? Because all three vendors offered their technicians up for the OpenXR board, so they're all involved, and you can tell. I am so far everything that I've done this, I'm really impressed with how it's set up. So while we can't remove the interface system from Go and just say OpenXR or nothing, because there are other environments that will unlikely go to OpenXR. ARKit, I doubt Apple will. Apple's abandoned OpenGL for their own metal environment, and while maybe one can argue that if the Vulkan specification would have been available earlier, they might not have gone down that route, but they have, and it is, so far it's their trajectory that they aren't sticking to open standards anymore. For a lot of things, they want to do their own standards, for good and for bad. ARKit. I love ARKit. As far as AR frameworks are concerned, it's really well built. It's an amazing interface. So I can understand that Apple's sort of going like, we've got our own ecosystem here. We can be, way at the front of this stuff. Why would we wait on the OpenXR environment to catch up? Although that's where extensions are for. That's one of the other beauties of OpenXR, of the spec, and the same of the Vulkan spec, is if you have features in your hardware that are not yet supported by the open standard, you make an extension. Okay, so someone needs to then implement your extension, and your extension will only work for your device. But you can get support for your device within this open standard, and piggyback on all the standard stuff that it does. So while I do believe that OpenXR will get the upper hand, I think there will always be outliers who do not jump on that bandwagon, and for which we will still need to do custom interfaces, because I don't want to let those go. There's a bunch of really interesting pieces of hardware out there, especially around the AR side. AR, most of the AR devices that are out there all have their own SDKs, because there still isn't enough of a consensus of how those SDKs need to work. For some of them, I really hope that they move over to OpenXR. For some of them, I actually am very interested in seeing if they are coming out with a good SDK, is actually using their SDK to create OpenXR drivers. But yeah, I think OpenXR is going to become the de facto way that we, at least in the VR world, it's going to be the way that we deal with devices. So Anyway, so yeah. So adding input sources via extension. So I guess that if you have trackers and stuff like that, it will have to be done with extensions. I have some simplified things. So example for the Daydream one, example for the Vive one, what sort of things we have. Vive Pro, got the volume things in there. Microsoft Xbox. So if you have a gamepad, those are all the inputs for your gamepad. Oculus Go, although I'm guessing that that's no longer supported. Oculus Touch. So here you can see all the different paths. There's a lot of overlap between all the different ones. Sorry, I got that itch. But yeah, for reference, they've nicely given us an overview of what these paths are for the mainstream controller things. And I think that's really where it's going to be interesting to see if we can actually request that information for the controllers that we have available. So so yeah, okay. I just want to have a quick look at this. Oh, my nose is itching. That's just some sample code, and we actually have most of that already implemented over here. So let's go and have a look at our OpenXR project. Oops. Where are we? I actually want to move some of these things around, but I'm not going to do that just yet because I think I'm going to get in the way of Chris if I do that. I just wanted to have a look at where currently we have the logic with all the hard-coded mappings. So hand tracking. So that's all the stuff that I built the other day. Extensions. Was it above here? No. Yeah, I'm gonna break this up a little bit more soon, so that it becomes easier to see which bit is what. Setting up our all our handles and stuff like that. It's currently only OpenGL on Linux and Windows, but I need to do more there. I am planning on doing more Angle. I actually downloaded Angle the other day and got frustrated as before because, oh, you know, for those people who are interested in it. So, this repository has been archived. Last updated 4 years ago. So yeah, again, they actually say it here. You know, they've moved over to Google. Whoops! Why do I always do that? I just want that to have as a tab. So Angle is now being maintained by Google, but the problem that we have, and where can I find that? Here we go. So here's the mapping between, you know, these different things going to different platforms. So that's kind of nice about this thing, is that it can map it to DirectX, but it can actually also map it to Vulkan or Metal. So this is one of the things that would have allowed us to still keep the OpenGL renderer working on iOS, even if they drop OpenGL support. But again, you know, we're going to be using a Vulkan to Metal layer. And the other thing is, you know, having Vulkan to DirectX at some point in time, which we need to look at. But this was the thing that really upset at me when I looked at this, is Windows Universal Platform is missing from this list. So while in theory I should be able to use the Google version of Angle to get Godot 3 running with DirectX on Windows, and in that way we would be able to use either OpenXR for Windows MR, or even though Microsoft has deprecated it because they want you to use OpenXR. Microsoft's completely on the OpenXR bandwagon, which is really cool. They've really, they've left their own holographic SDK. They've abandoned that, I think. It's all OpenXR. If you want to develop for the Windows MR ecosystem, you want to do that. But the problem that you have is that if you want to run your application on a HoloLens, which would be completely possible if I could get Angle to work, is that Google's Angle does not support Universal Windows Platform. Now, I have no idea if I could compile the Windows version of this so that it runs on UWP. I'm not sure. I'm not experienced enough with Universal Platform. But it's a problem because that's what we need to run Godot on the Xbox and run Godot on there. So Godot currently uses Angle, this one. It uses a specific build of this, which unfortunately you have to go back, because this was the other thing that's a problem. You can see that there's a holographic experimental one in there. That one's even older. This is all set up to be compiled with Visual Studio 2015. So we're now on 2019. Getting this to compile on the latest compilers of Microsoft is a bit of a pain. I'll get there eventually, and then hopefully if I get the latest version of Angle compiled for Universal Windows Platform on the latest compilers with Godot, I'm going to see how far I can get on making OpenXR work with my Windows MR headset. Because in theory, that should be a matter of compiling our OpenXR plugin for Universal Windows Platform with a little bit of DirectX tweaking, but I think we can get away with that. And in theory, it should run on a HoloLens. Yes, they had this special holographic version, but what that did was enable all the parallel rendering optimizations that Microsoft did. Without that, we should still be able to get it to work, but I will never know. I'll have to give it to someone who has a HoloLens. I don't have one. So yeah, that's a little tangent. It is something that I really, really, really want to have a look at and get to work. Even if it's just to see how well the compatibility is. Because eventually, obviously, we want to have Vulkan to DirectX. I don't know if there's something good for that. No, it's only comparisons. That's a shame. I'm sure there is a compatibility layer somewhere, just like we have Molten VK for Vulkan to Metal. At least I hope so, because that's what we are going to have to get get things running on the Xbox. For those people, there's quite a few Godot developers targeting Xboxes, so I want to be able to keep doing that. So yeah, it's probably going to be a little pet project of mine in the long term, because my stake in it. I want Godot to run on the HoloLens. End of story. I think Godot would work on that environment so well. We could make a real big difference there. Anyway, let's get back to what we're really doing today. So again, like I said, this is all the initialization code, which is basically just doing everything in one big file swoop. And I do want to break this up so that we have a little bit more, that it's a little easier to find everything. So that's our projection layers. It's all good. Okay. So from here, we're starting with our action sets. So right now, like I said, we have our action sets hard-coded. And I think for tonight, just to get some experience with the seeing whether everything works, the triggers and stuff like that, we'll probably expand on this a little bit. But I want to start thinking about, okay, how can we make this configurable? And we're just going to see how far we get there. So you're going to indeed see we have, our clicks. It's all hard-coded to paths there. So that needs to become settable. So we got our A and B buttons. And here you can see that everything is mapped to full instruction. So this will only work for all controllers that have that same thing. So for instance, this one, input A, that won't work on a Vive 1 because a Vive 1 doesn't have an A or B button, and it'll error out on that. So yeah. Now this is the other thing which is really interesting, is I think the okay, so it does have some amount of mapping here. Oh, okay. Oh, that's pretty pretty neat. Ha! Okay. All right. Direction. And we don't have the flow directions. Path, path. Hold on. Hold on. Impose path for each hand. Oh, how are we doing the hands here? Where's my auto completion? Why does it not find that? Why does it not find my lookup? Maybe in here. Good. There we go. Where's defined? Okay, we're gonna go all the way back to the beginning. Hold on. Just define atom. This is an object. Okay. Hold on. What am I missing? Because we have select collect path 2. Because we have one for our left hand and we have one for our right hand, hard coded. But then here, oh, okay. Okay. I get it. So we're actually defining the same paths for each hand. Okay. Let's go and have a look at suggest. That's probably a method of mine, isn't it? Yes, it is. Okay. Oh, that's what he's doing. Okay. Okay, so basically what we're doing here is we're setting up these paths. And these are actually paths for each controller. Where are we setting the actions? Oh, okay, so we've actually defined the actions. Right. That's interesting. So this action, trigger button, is the action that we will use in game, which is, I no longer have that open. That was done. Where's my action bar? So, the downside of Sublime, that if you don't make sure that it's stuck to the thing, then it just opens up another file over it. So here, we're in actions, we're defining our actions. And then in our mapping, we are mapping. In OpenXR, we're doing that in code. So we're defining our actions here. In this case, in code, obviously, we don't want that in code. We're going to be wanting to do that in, a UI style. So we define each of those actions. We create those actions. Then here we create paths as objects. It's just to create, a path representation of that string. And what we're doing here is we're saying, okay, these are our bindings for a simple controller. These are our bindings for a valve controller. These are our bindings for Monado. And again, right now, all hard-coded. This should not be hard-coded, but everything is being hard-coded here. All good. Now the big question is, how do we now determine which one of these bindings we are using? And I'm guessing that is because of these interaction profiles. So we're basically saying, if you find an index controller, use these bindings. If you find a simple controller, use these bindings. If you find an Oculus controller, use these bindings, etc., etc. So we're basically giving all the mappings that we've configured to OpenXR. And OpenXR is now going to say, hey, when my index controller becomes live, those are our mappings. Which also should, in theory, mean that we're probably not going to... Oh, that actually explains why we weren't having all the interaction with our hand. Because it's actually not recognizing my touch controller. It's probably falling back to simple controller because I haven't defined mappings for this guy. Well, Enrico, remember, this is right now all hard-coded, and I'm just looking at how it works. This all needs to be changed into a system where you can define those mappings. And whether that means that we're going to have some sort of JSON loader that we're going to build ourselves, or if we're going to be doing it on the Godot side, that's something for Vive controllers. Because indeed, those need to be in there. Now, one of the things that's really interesting is that there's left and right already in here. And again, here we go through the different hands. And this is, again, one of those interesting things where in our OpenVR approach, we're not assuming that both hands have the same actions. Kind of makes sense to do this, but I think eventually once we have those bindings, we're going to let that go and say, no, we're going to do that differently. But again, that's just thinking out loud of where we're going to get to. That's just our action space. Yeah, I was getting angry with it, Microsoft, because Microsoft is is not very lenient when it comes to defining these structures in this way. This newer syntax isn't completely compatible between the Linux compilers and Microsoft compilers. It's really annoying. Although Microsoft does say that, the latest C++ dialects, they haven't fully implemented yet. And they might remove that at some point to make compiling easier. Because right now you can only compile this with the latest compilers from Microsoft. So this is purely our orientation. So I guess that's mostly around poses. So I'm not too worried too much about that right now. And we bind them for the left-hand pose and then the right-hand pose. And again, this is going to be interesting to see how we're going to deal with this if you have additional controllers. I need to read up about that because I'm not entirely sure. And we can see finally that we are mapping our AR/VR controllers right away. So this is again one of the problems that I have with this being hard-coded, is we are assuming that we have a left hand and a right hand controller. That's kind of safe to assume, but we're also assuming that they're available from the get-go, and it'll actually spam errors when you haven't turned one of your controllers on yet. And not everybody is going to make games that even require controllers, so that needs to change. And eventually do our hand tracking, which is a little less hard-coded, but still pretty hard-coded. So we don't have joystick inputs here yet. We have our triggers, but we don't have our joystick yet. Okay. And we also don't have our touch controller yet. So pose path is purely our location path. So how is that within the initialize hand tracking? Let's have a look at that. Check if hand tracking is available. All right, so that's where OpenXR is kind of saying, well, you either have it or you don't. They don't really and I remember that because when we implemented this, I think, did we do that on stream? I can't remember. I think we started it on stream. But it has this predefined hand skeleton that you need to adhere to. And that also the vendors need to adhere to. So that's pretty cool. Is it any easier with Linux compilers? I don't use Linux, so I'm not the right person to ask. But two things that are important with Linux. One is that the OpenXR plugin was first built in Linux because Chris works in Linux. But the other thing that I've heard is that a lot of the core devs that are working on OpenXR are all working on their Linux, which is really interesting, seeing that Oculus currently is Windows only. So it might have been that the people that I was talking to were all Valve guys. But there's a lot of Linux developers there that are working on that. So especially on the Valve side, obviously, the development there is pretty well supported. On the Godot side, same thing. I would say that the Linux developers in the Godot community outnumber the Windows developers. I could be wrong about that, but that's the feeling that I get. Again, because, Godot being open source, it attracts, a lot of developers who will likewise choose an open source operating system. Plus that sconce takes care of most of it anyway. So yeah. The people that I know who are working on the Linux have no complaints. Let's say it that way. So I'm assuming that compiling on the Linux is pretty straightforward. And again, if you want to do VR development and you want to help out fixing things on the plugin, or whether it's the OpenVR plugin or the OpenXR plugin, and you happen to work on the Linux, there's a whole bunch of guys on the Godot Discord XR channel who are working on Linux. Ben's working on Linux, who is one of our OpenVR maintainers, who is doing all the overlay support. Like I said, Christopher, who did the first pass of the OpenXR plugin and is still involved with the OpenXR plugin. He's a Linux guy, so yeah. So yeah, I would say that especially if you are in the, if you're okay with using SteamVR, you're pretty well supported on the Linux side. Okay, So now I need to find where we started. Um, so I think I'm just going to put the joy, because that's the first thing that I wanted to do. I wanted to help DS Snowpack out. Why is this all complaining? I don't know. I wanted to help DS Snowpack out by looking at what the joysticks are doing. So that's something that we're going to add in. But before we start with that, oh, really? I'm not going to do that right now, guys. Sorry. That's what you get when, for the last couple of weeks I've been using the index, and now I connect this and I need to update stuff. We're not going to do that midstream, so hopefully it'll keep working. I also need to quickly grab my index, and we'll start working some more with my index. XR plugins, Godot OpenXR. So I'm on the hand tracking thing, which I don't want to be on, because I merged that into master the other day. Pull that just to be safe. Did I already? Maybe I didn't. Hang on. Did I already merge it? I wanted to merge this. I didn't yet. Let me check if Chris is online. Where are we, guys? Sorry, I'm just having a quick check and see if Chris is around. So bear with me for a second. Yeah, Ryan, I can understand that the index is a pricey little guy. And that's really the only downside of the index. I've said this before, from all the headsets that I own, both the ones that I bought myself and the ones that I've been gifted. So obviously, my Rift Fs that I'm using tonight was provided by Oculus, and my index was actually provided by Valve. So I'm very thankful to them both for providing that, because that's helped greatly in improving XR support in Godot. The index by far, as far as using VR, as far as playing games, is my favorite device. But you compare it on price, I don't have the prices handy between the Rift S and the Index. Yes, the Index is better than the Rift S, in my opinion. Is it 2 or 3 times as good, which would be suggested by the price? No. For the price, if you purely go for price point, everybody who comes to me and says, Baz, I want to get into VR development, what do you recommend? I don't have a big budget. I give people 2 options. Either go for a Quest, if you're interested in also, going after the mobile market, or go for a Rift S. I love, as far as development is concerned, I love this thing. And I have 2 reasons for it. Well, actually 3 reasons. One is price. Of course, for me, I got it gifted. But my main reason as a developer is this: the Halo design. The Rift S right now. Well, no, that's a lie. The MR, because that was the reason I was using my Acer MR system for, even though I had the original Rift, which is even with its lower resolution, but the original Rift together with the original touch controllers has been one of the most comfortable headsets to develop with. But they have a problem, and that's what the Index as well, and the Quest actually as well. They're all ski mask design devices, and this one is a Halo. and the MR headsets are usually also Halo. And the MR was actually even, or the Acer MR was even better because it had the flip up thing, right? So that headband is incredibly uncomfortable on the MR, on the Acer MR. But you put that thing on, and you could flip that thing up. So you would just keep it on, you would flip it up, and then you would work again. With this guy, obviously, if I'm testing something, I need to then take it off. But taking it off, put it on, take it off. Do some programming. Compile. Put it on, test, take it off. Comfy. Do that with the index. Half the time I lose my glasses. And again, you know, the ski mask design, when you're playing games, the fact that it encloses you, that you don't have light leak on the inside, you know, the same problem that I have with the PSVR, which I still to this day think is the most comfortable VR headset that is on the market. For all its faults, that is where it shines. For development, as a developer, I love that because you're continuing. But when you're playing games, obviously, you know, playing something like Half-Life Alyx on an index is amazing. You know, the tracking is amazing. I think if you have the room for it, you know, the lighthouse tracking is, you know, better. But again, it's not price-wise. It's not comparable. You know, that's the thing. You know, the Rift S costs a fraction of what an index costs. So yeah, and again, everybody needs to decide for themselves, and I think every headset as a result has a place in the market. You know, the index is one, you know, together with the HP Reverb. They are the top of the line devices that you currently can get, and the quality is, you know, justifies the price if you're willing to splurge on that. But I think that's the market segment there, right? If you're on a budget, get a Quest, get a Rift S, or if you're on a really tight budget, go for the MR ecosystem. Okay, the controllers are horrible unless you get the G2. But again, like I said, you know, when I started doing VR for Godot, you know, obviously the early days, 3-4 years ago, I actually only had the PSVR, so I was using this thing called Tribal VR or something, or Trivial VR or something like that. I can't remember what it was called. But it was this thing that allowed you to use the PSVR on Steam VR. That's how I began. And a friend of mine had a Vive, so I would compile Godot, see if it worked on my PSVR. I didn't have any tracking or anything on the PSVR because that all didn't work. It only did 3DOF stuff. I still had to use the breakout box and trick it into thinking that it was attached to I think I actually had to keep it attached to my PlayStation and have my PlayStation off, but then the HDMI plugged into my computer just to get it to work. That was hilarious. And then I bought the Oculus Rift, which I still to this day, like I said, I think, you know, was an amazing device. You know, it's outdated now, but, you know, it's still an amazing. And even there, you know, right now, because of the Rift S and because of the Quest, if you're on a budget, the secondhand original Rift isn't that expensive. And I still believe that the touch controllers that came with the original Rift, well, you had to buy them separately, but because they weren't available from day one, is amazing for development. But then Microsoft was the first to that actually made the Acer MR development headset available, which is cool. So we actually got that as part of, you know, Godot and Microsoft working together. And that's the thing, is, you know, I got that one, and while in many respects I found the Oculus Rift better for developing, you know, I used the Acer, and it was purely because of the flip up action. because not having to take that thing on and off again. And again, I hate the headband that came with it. But as a development device, and again, when you're developing, you don't care that the tracking isn't perfect. You don't care that the controllers aren't the best controllers. You care about being efficient with your time, and then you build your game, and then you run your game on the better headset to actually experience your experience at a better level. That's where it gets to. Hold on, I'm actually gonna do this on my phone. I doubt he's awake because he's in Germany, if I'm not mistaken. And I really want to merge the stuff in. Let's see if he reacts, because if we could merge this in, that would be really good. Let's go back to here. Tin, that's the other problem is indeed availability. I'm surprised. I really am. Whether it's the Quest or whether it's the PlayStation 5 or whether it's I think the Xbox One is still available to buy. There's so many devices right now that are hard to get. Some of it artificial, I guess, but I think a lot of it's to do with the pandemic as well. Again, I got lucky because of I think I was one of the first people in Australia, and possibly also one of the only people in Australia who actually has an index, because I don't think you can buy an index here in Australia at the moment either. So yeah, I got pretty lucky that that Valve, it's fun because obviously Oculus is now the first one who has said, we want to financially support you guys because we really see that what Godot is doing in VR has promise, and we want to help you guys excel at this. Valve is they're interested in helping in other ways. And obviously, that's all we negotiate. I'm not part of those negotiations, but I know that there's talks there. But the talks that I've been involved in, around the time that I think last year sometime, when they actually reached out to us and said, we really like what you guys are doing. Are you interested in supporting the index? Talking to those guys and seeing how enthusiastic they are about what we're doing. Yeah, pretty cool for a small group of open source developers. So yeah, pretty happy with that one. Yeah, Tin. Yeah, like I said, I think I'm one of the only people in Australia who has an index, so I count myself lucky. There are others, of course. Valve has supplied indexes to a bunch of the top developers that are around, but I think it's in scarcity around here. Oh well, if it's 1 p.m. in Germany, then I'm assuming that well, he might be at work. That's the other possibility, of course. Yeah, Ryan, that's your choice. I did talk a lot about that in the last stream about the choices that Facebook is making. I'm to this day still a big supporter of Oculus and what they're doing. Facebook Reality Labs nowadays. Like I said on stream last year, the people that I deal with there are really enthusiastic people who are seriously doing good for the VR community. But I have my questions about some of the choices that Facebook is making, and like I said on stream last night, I think it'll get right in the not too distant future. I've said it many times. I think the only thing that is really required in that space is a proper competitor on the mobile VR market. because right now they can get away with a little bit more than they might want to do if they really think about it. And again, I do think a big part of it is a storm in a glass of water. I do think people are overreacting, but at the same time, it's I can understand that that for some, needing a Facebook account is too much. But like I said, there are other options. Still on the more expensive side, the HP G2 is a lot cheaper than an Index, and a lot better than most of the other MR things on the market. But you can still get one of the older, the older Rifts. Yeah, I think even for the Rift test, because you still need to install the Oculus software, you probably still need the Facebook account at some point. I don't know how far it'll let you go when you install that. I actually never really paid it, because I do use Facebook. I do have a Facebook account. For me, it doesn't really matter. I do laugh about it because all the all the people saying, well, but they're tracking your data and what you're doing. Well, they're tracking my daughter because she's playing with the Quest more than I do. I develop with this stuff, so I'm testing stuff out, and that's not going to give them anything valuable. It's my daughter who's using my Quest to play Beat Saber whenever I'm not using it. So yeah. But yeah, other options, there are plenty, and especially I would look at the if you're on a budget, I would look at Windows MR. Get a like a Lenovo MR headset, or I guess you could get one of the Samsung ones, but they are more expensive as well. But you can find them secondhand pretty cheap. You very often have pretty cheap deals on Amazon for especially the Lenovo's and the original HP one, so not the Reverb G2 one, but the original MR headset. And again, I don't like the controllers, but if you're just interested in developing for VR and you want to start on the budget, those are really good headsets to just start with. Do check if they work with your computer. That is the only thing that is sometimes a problem, is that if you don't have the right USB ports with the right throughput, you can be in for a nasty surprise. That I've heard several people have problems with their MR headsets because I think it has to do with all the camera stuff that goes through to do, because I think it does all the camera image analysis on the PC itself. It doesn't do that on the headset. So let's see what else I'm catching up on. And Burnt, yeah, the DK1 and DK2. I never had the DK1 and DK2. Like I said, the original Rift was my first proper headset that I bought. I got the PSVR before that. Most of those are indeed gathering dust right now because I've got newer headsets that are much more enjoyable to play. Although I do wish I did more with my PlayStation VR. I really would want to develop for that platform, but who knows? Might happen someday. But yeah, if I ever get a proper room for my streams, if my YouTube career takes off, then I'm going to have a cupboard or something behind me with all my headsets on display. I'm purposely keeping all my old headsets, so even if I don't use them, I'm keeping them because I think it's just cool to have them for nostalgia's sake. Yeah, the Clean, yeah, the like I said, the original Windows MR HP headset. I think the HP one and the Lenovo one, those two were, they were still pretty budget, but they had the better headband. It was the Acer that had, or maybe even only the Acer Development Edition, because I think that Microsoft probably only gave the cheapest version away to developers who requested one. Yeah, with because I remember that the guys who were doing the Visospace stuff, the Alto, the locomotion device that I played around with a couple of years ago, they all had Lenovo's, and those were very comfortable headsets. But they had the flip up thing and everything. So as a developer headset, I love those. I just think it's so much better. Yeah, fellow Horde collector, indeed. Um, I still don't have a Quest 2. I only have the original Quest, so I can't compare the Quest 2 to the original Quest. I don't know. Okay. Oh, that's one way to do it, Ryan. Yeah. I guess I just got lucky with this laptop here. Because I use laptops, I don't use normal desktop machines. Um, Basically because I want to be able to take my work along to meetups and stuff like, which aren't currently happening because of the COVID stuff. It's a bit of a shame. Um, Although if this new outbreak has run its course and our government doesn't make the same mistakes that are being made abroad, and we actually will see some light at the end of the tunnel of this whole thing, and hopefully eventually we will have um, some meetups again. Still want to do a proper Godot meetup here in Sydney one of these days. I did start the Australia Facebook page for Godot right before the pandemic hit, and yeah, let's get all the Australian developers together and do something. And all right, that ended pretty quickly. But obviously, at some point in the future, we do want to do that. But that's why I've got laptops. But yeah, at some point, I need to get a proper desktop as well, just because of the performance possibilities. And then you get the Reverb G2 is amazing, but not budget. It's a lot cheaper than the Index, but it's still a lot more expensive than say a Rift S. So it's right in between those. So I think they're for the quality that you get, the price is right. But it's not a budget option. Your personal spammer is spamming everybody again. I still have to laugh about your name. You know what? I'm glad that you're serious and not somebody who's out here to ruin stuff, which your name would suggest. But welcome again. All right. Anyway. Yeah. I don't get it. When you look at how big a 2080 GTX card is, and to think that there's a 2070 RTX in this thing, I'm pretty sure to tone down 2070 RTX as a result, because I can't imagine it dissipating the kind of heat that a proper card uses. But for what I do, it is more than capable. But I do think at some point in time, I do want to have a proper device. I haven't heard anything from. All right, you know what? I'm gonna stay on my hand tracking branch. Checkout hand tracking. But we're gonna create a new branch here. I'm just gonna call that test. The thing is, I also wanted to start working on the. Let's do this as a test first, and then we'll start. We'll start working on some of the other stuff that I wanted to do. Which reminds me, what did I put in here? Is it purely? That's just all that stuff. This is where I miss GitLab. GitLab gives me a nice little file overview to just see which files have changed. Because I've rejigged the structure, the folder structure a little bit. And obviously, I don't want to stray away from that. Anyway, let's just see how far we can. Let's first do the joystick thing, because that was the whole thing that I want. And I think that I need to put an entry in here. Actually, I think I'm going to copy the valve index because we're going to have similar paths for that as well. Okay, let's touch controller. So let's go over here and have a look at what. I'm gonna go back where those paths were. Here we go. Oh, interaction profiles. There we go. So that was a simple controller that we just did. Don't right now care about the Daydream. So I don't have a visor test on it, so I'm not going to do that just yet. Xbox. Oculus Go. Now here we go. Touch controller. So again, I'm hard coding it now, but that's not really what we want. I need to start thinking about what we're going to do there. But I just want to make sure that I have my Oculus touch controller here, so that we can see what we can do with that. Now the next thing that we need to do is get our joystick input. So, because here's the thing, right? Left hand is X, right hand is A. And here we have A and B. But we have an A and B on both controllers. So here is where it actually already falls apart, because of the way that this is currently built, where it is assuming that we're using the same paths for both hands. Oh no, we're not. We're not. That's right, because here we got left A. Okay, so we can go and duplicate these, and now let's have a look. So we have on our right hand A and B, and on our left hand we've got X and Y. And Y is B, X is, okay. So here I'm going to say AX and BY. And again, I'm hard coding just to test this stuff and make sure that it works. And let's see if this is actually working as an input. Oh, and here we have the difference between X click and X touch, which is for the capacitive touching. But because we've got the skeleton thing working anyway, we don't really have to worry about that. But otherwise, it is indeed the same. So on the left hand, it's going to be Y. On the left hand, it's going to be X. AX, AX, BY, BY. Excuse me. And we've got those in there. And that means that here we now need to use our other paths. Okay. So we got those. So now we have to have a look at our joystick. So we got our thumbstick, X and Y. That's really the only ones that I care about. On our valve index, we also have thumbsticks X and Y. So, but here we also have a trackpad, because this guy has a thumbstick and a trackpad, but only a trackpad in one direction. So the MRs have got a thumbstick and a trackpad in all directions. And the Vive ones only have the trackpads. And this is again where it's going to become really important to not hard code this and do proper mappings, because you need to make sure that we have a certain input requirement, but every controller might implement it differently. But for now, I just want to hard code the thumbstick logic in here. And we need to go and get that as an input. Now, the interesting thing is, actually, let's define these paths first before we lose them. Before I forget about them, so path, that's going to be thumb X path. And that's going to be input thumbstick X. And that's the same for both controllers, because they both have them. And now we need to do the same for our Y path. Excuse me. Y. But now the thing is, those are separate. Okay, so we need to have a look at actions. So we got actions, we've got our action sets, which we are already creating because we're now just building. Because again, you know, we eventually want multiple action sets so that you can turn them on and off. Right now, we just hard-coded a single action set. No, that's part of that. That shouldn't have an empty line in there. Okay. Now we're going to go and create an action. So the reason why I want to have a look at this is because I wanted to know that. So here we got our create actions that calls our create action. Action set must be a valid action set. Info to an action create info, and the action must be, that's our output, our XR action. So a bunch of error codes, it's fine. So here we got our create info. The name for the thing, type for a thing. What's the sub action path for? Just name, I guess. And then the localized one. With elements in the sub action. If the sub action file, no, this parameter should be 0. This array is specified and contains one or more sub action files of application. Create the action set file. And then we have our action types. So we got a float input, and we actually want to use a vector2f. But that suddenly means that we have a combined one. So let's see. If we look at our create action here, I wish there was a back for this. Action type, sub action pass, and pass. Oh, okay. So here we're defining that we want to use this action on both hands because we're always linking them to both hand paths. So those hand paths were defined earlier on, one for a left controller, one for a right controller, and we're binding this action to both. This is part of making sure that if we map both to them. Okay, so that makes sense. The thing that doesn't make sense yet to me and that's probably part of the suggest actions. Okay, we'll go back. Okay, so I can't do that. It's so annoying. We'll get back to that in a minute. We first are going to create our action. All right. So we want a new action. No. Take the sneeze. Oh, sorry. All right, let's have a look. Where are you, buddy? That's the scenes. I'm looking in the wrong place. Here we go. Is that defined over here? Hopefully it is. Here we go. So here we need a new thumbstick. There we go. Let's first copy this. And now I see a bug here. That needs to be there. That's obviously wrong too, because that means that if any one of them fails, that's where it ends. But, you know, I'm not worried about that right now. So, We need this one. There we go. So we've now created our action. Very cool. We've got our paths. But now we have a problem with how we bind those paths. Fine, we got to be able to destroy our actions. That's fine too. Input actions and output actions. Yeah. Cool. Okie doke. So here it's going to tell us about the suggested binding. So again, what we're doing right now is we've told OpenXR what are the actions that our game wants to react to, which is what we defined here. We have now created paths for all the paths. Those are just strings. But now we are defining mappings for every controller to say, OpenXR, this is how I want that to be mapped. And again, that needs to become an interface of some sort. And then OpenXR is going to choose from those profiles which ones it's going to apply to whatever controller is active. So we're not limiting ourselves to the controller that the user is using. We're giving all the controller profiles, and then we're leaving it up to OpenXR to do something with it. Parent input of the values instead of the input values themselves. There we go. And that parent path must contain subpaths x and y, x and y. Okay. Okay. So we've created our paths here all individually. But obviously there is a subpath option in paths. Okay, so we need to go back to paths. So basically what we're going to be doing here is creating a thumb path that is going to combine those two into a single one. Okay, but how? Actually, let's have a look at the sample code that we had over here. Does any of this do? But here we have our actions created. Cool. Okay. But this only does a click and a haptic. There's no example of a vector one. That's a shame. Okay, so we really have to figure out how to do a subpath. Okay, let's treat the path. Here you go. Subpath. Devices on source side of the input system needs to define paths for each component down to an action. Okay. Check that. Yeah. Okay. When the runtime is based on bias, the suggested binding path must refer to the parent of input values instead of to the input values themselves. And that parent path must contain subclass X and Y. Bound to X and Y have a vector respectively. In any other situation, the runtime may provide an alternative binding to the unbound. But how does it do it? That's the thing. Would it be nice if they had an example of that? Is there an example in the GitHub? Well, it's a Microsoft one, but it's okay. But I don't have any control over this. All right, what if we just go and do a search on this and see if anybody has some examples? Okay, that's not much help because that's already what we read. Okay. Do we go back up to where we started? So you can string put the path for the direction profile, that's fine. Now I'm going to do the binding here. Path is top level user path plus input source path. For example, hand trigger click. Yeah, that's what we just read through, and that didn't become clear because this is what I don't get. You know, the first bit suggests that they basically want us to do. Where are we? that they actually just want us to do this. And maybe that's just what we're going to test and see if it works. Because that's what it seems to suggest, that we just get it on the parent node, on the parent path, and then it must, it will use X and Y. But then it says that that parent path must contain the subpath. Or do they mean that this will only work if we have a path for which an X and Y exists? Sorry, I hit my thing again. It must be. It's the only thing I could think of. Let's just see. Let's just see if this works. So menu action. So that's A and B. It's fine. So we want to have it's called thumb. Forgot what I called it. Thumbstick index. There we go. So we're gonna say, well, we want to go and map that guy in both of them, and that's gonna be thumb path. Why am I not consistent in my naming conventions? Needs to be camel cased. So let's do that. Okay, so that in theory should ensure that our action is now mapped. So now we get the situation where we have our actions that we are going to be working with in our game. We have them mapped on the individual controllers. So we obviously do not have them mapped on our simple controller. So on our simple controller, there's no joystick. It doesn't work. And again, we'll do something else with this. I'm actually thinking about mimicking the JSON approach that we have for OpenVR and creating some sort of file. Or we're going to use a config object for it. I'm not quite sure yet. I actually have to do that last thing. I'm not sure yet. We will figure it out. We will. All right. Get those controllers. So now we need to have a look at where are our... Okay, so this is our action states. I'm guessing that this is the one that we're supposed to be using. Okay. Well, that's one way of doing it. Okay. So, reading our input action state. That's what we're basically doing right now. So we got a different states, flow Boolean. So we need to have a state vector. So that's our get action state Boolean. All right, let's go in here because we can implement that here first. We're gonna get a new case, XR type action states. Okay, why can't I see my vector state there? Oh, that's my input type. Do I need to get them individually? That would be pretty crazy. Let's have a look. State float. Yeah. Here we go. XR get action state vector 2. Hang on. See, we do have a vector 2. It's just because we haven't used it in here, the auto completion wasn't working. Ah, got a bit confused there. Oh, that's interesting. I usually put my break here, but I'll stick to Chris's way of doing things. I'll go and copy this, even though it needs to change. All right, so action state pose. Okay, so this is obviously not pose. We're now action states. State vector 2. There we go. There's that. That is that. That now becomes this. Come get the vector. And there we go. All right. In theory, that should do it. Okay. Boom. States and count. Got action states. So in this case, it's going to be thumbstick action index. Now our autocomplete should work because we've used that before. And that's going to become thumb states. Okay. Well. Alrighty. Let's just look it up here. Easier. That was it. Oops. Yeah, of course. That's the one that did I copy that wrong into code as well? Let's go double check that. Yeah, I did that good. All right, cool. So we're going to get our current state, which is a vector 2. Perfect. Change since last sync. Yep, that's in there. And I don't care about the other two. So I just care about this is going to become thumb states. And that's going to be thumb states. So we're going to say if it's active. Is there indeed an active on there? Yep, is active. So if it's active and it's changed since the last time we're used it, we're going to change that one. So I'm just going to quickly go to the definition here, because obviously we're not going to be using that one. We're going to be using that one. And in this case, because this is for backwards compatibility, okay, that's going to be interesting, because I think I need to map that to... Oh, we got 2 of them. That's right. We've got 2 of those. Okay, that's pretty cool. So in this case, where is that defined? Button. Okay. X-axis is going to be 0. Actually, I'm going to call that axis. Oops. X. And it's going to become Y. So this becomes axis X. And I'm assuming that's going to be like that. And Y, because I remember we send the axes separate. In Godot, each axis is a separate axis. Alrighty. In theory, that should do enough to hardcode our joystick thing in there. Oh, we're done. Almost 12. Okay. Scones platform is Windows. It should be enough, I think. All right, we've got errors. T possible. Oh, those are just warnings because that library just doesn't like that. Okay. Clean up some of the stuff eventually, but that's fine. It's just all unreferenced. So our first error is result states undeclared. 1020. Scroll up to 1020. And see what we got wrong. 1020. Okay. We are defining result states here. Because I'm missing a semicolon. Okay. Start there. All right. Warning, error. Boom. Too few. Oh, because I forgot the true and false. There we go. And both need to be true because they can be negative. True. True. If it's false, I'm expecting a value between 0 and 1. So like a trigger. And right now we don't have any of the triggers embedded. And in that respect, we probably should double check what we were doing, but with the other things, see if we are using the same stuff. Oh, yeah. Okay. So it compiles, but doesn't like it when you keep this open. So let's just quit back. And now I should be able to open up my new version. Now, obviously, we're not doing anything with our left and right things yet. So maybe we should put a little UI to that. And again, this is where I really wish we had already merged stuff because I'm going to have to do this twice now. Then again, let's see if this maybe has an old... No, this is a really old version of VR Common. That's the problem. All right, so let's go and say XR tools. There we go. That's usually the only way to come on. This happens from time to time on my computer. It just decides to hang for just a second and then it's happy again. I'm not sure what's causing that, but something was keeping it busy. Where are we? My assets. There we go. XR tools. Add-on. XR tools. Okay. So let's go back to our project list. This is the sort of thing that I really want to do when Godot is not running. Because we're going to have to fix a whole bunch of dependencies, most likely. And now we're going to delete this guy. That was not my idea. All right. Tools. Deleted its contents. Anyway, we got there in the end. All right, let's see how many things we need to fix up now. Well, I don't think I'm actually using anything in here because there's none of the the things are actually in here. That's kind of handy. All right. So what I want to do here. No, that's wrong. I wanted to add our viewport 2D and 3D, and I'm just going to do it for my right controller now so that we can see what's going on. There we go. Controller info. There we are. And it's a little too big, so let's make that a bit smaller, something like that. Somewhere here we now have a display. Now we don't have a scene for that yet, so I actually don't care about the collision layers either, because we're not going to make this interactive. I do want it to be transparent. That's cool. So now we're going to add a new 2D scene here, which as far as I can concerned can be a node 2D. That's fine. So this is going to be called controller info. Now we want to have a color rect in the background, which will also serve us as something that allows us to see the dimensions. So we were having a display of 300 by 200, which may change. Give that a bit of dark, and then make it transparent. I just want to be able to see something. We'll throw that in here for now. That's fine. Okay, so that is going to become our controller info screen, which means that we can now actually see that guy. Move it up a little bit. There we go. That's probably going to be really badly orientated, so we probably need to change the orientation of that thing. And again, you know, it's not going on the left hand, it's actually going on our controller. But that's okay. All right. So what I now want to do is let's put in a VBox. And I want to make that a little bit offset. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's all fine. And now we're going to be a VBox container. I'm probably going to rename that. Grid. So this one we're going to call thumbstick X. There we go. And I'm going to add a label in there. And that one's going to be thumbstick X. There we go. And with that, I want to give that a minimum size of 100. There we go. And now I'm going to add another label, but I'm going to call that value. And I'm going to right align this one. And again, our minimum size is going to be 100. I'm just going to call that 0.0. I'm going to do a Y in there. Make that label Y. Okay. So this needs to have a script. I think I'm going to go and cheat here, because that scene is going to be instantiated under here. So let's go and have a look. That's our viewport. So it's going to be underneath our viewport. So our parent of our parent of our parent is going to be 3 levels down. So in my process, I am going to say var controller, ARVR controller, get node 1, 2, 3. I know this is really ugly, but that's just what we're going to do. All right. So when we look here, we should be able to get our joystick axes. So we had 0 and 1 there. So what we simply should be able to do is colorect value dot text is f controller dot get joystick axes 0. Before I do that, I do want to do if we found a controller, then we do that. Oops. And now we do the same thing for Y. There we go. Let us see if that works in one go. I'd be surprised if I did not make any mistakes. All right, so. Come on, wake up, little headset. I was afraid of this. No, it's still loading up. Okay, just takes a while. It went all the way to sleep, I guess. Now, the problem that I do have is I'm now going through OpenVR. We might have a look at what happens if I actually go directly through the other one. It's kind of stuck. I'm actually going to go and close that and close that. Let's go back home to our... Just restart it, because I have an idea that this is completely crashed on me. I was trying to do something. Okay. See, it's spamming us about the controllers. Okay. I'm just gonna go and restart this stuff. Go and restart my little headset guy. Let's see if that helps. Now I've got a white light. That's promising. But it's still starting Oculus. Very good. I bet you this is because it says I need to update my drivers. And I'm going, I don't want you to. Come on, load up. Yay! It's starting to breathe again. All right, I can see my screen. Ooh. But my thumbsticks are not giving me any inputs yet. Which could be that our code is just not working. So let's go over here and see if we can put a breakpoint here. There we go. Got some errors. That's fine. All right. So debug, step over. All right, we definitely have a controller node. All right. All right. I'm getting logs. So, hey, look at that. We have actually found our Oculus Touch controller for our profiles. That's really good. Ten bindings, perfect. 8 bindings, perfect. I still need to fix that one. That's fine. Now, interestingly enough, those outputs should actually be coming in our output here, which is... Oh, it is. Okay, thought so. Still some prints in there, but that's okay. Now, there's a couple of things that could be wrong. One is that our values here could be wrong. Var x load. No. And if that doesn't give any output, let's make sure that it runs first. Okay. All right. Now we're absolutely getting 0. So we're not getting new values. So that means that there's still something wrong in our plugin itself. Okay. For me, game development has been a long-term hobby. I started when I was in my teens, in the mid-90s. Did nearly work in the game industry. Still have the wish to at some point do that. It kind of is coming true now that I'm going to be working for Godot, I guess. But yeah, I'm a hobbyist. Always have been, but been at it for quite some time. And I just love VR. That's just something that I found a passion in. I started having a lot of fun with. All right, so so this is going to be one stick. Let's just see if we're actually getting anything here. Because now it's a matter of figuring out where did we go wrong with it. What do I have to say about VR on Godot? That we are getting better and better. Performance is really a difficult thing to answer. When you compare us to the performance of Unreal in VR, or if you compare us to the performance of someone building something completely from scratch without a game engine in VR, we're definitely not up to their level yet, you know, especially if you look at what a lot of the Oculus games do, like, say, Robo Recall, which has been completely written from scratch as far as I... No, that's actually also running in Unreal, isn't it? No, I think that one is running in Unreal. Can't remember which one was being done from scratch. You know, these guys have been at it for a little bit longer than we have, so... plus that we were having some problems with the OpenGL stuff not working as well as we hoped. So it's going to be really interesting to see what the new Vulkan renderer does performance-wise. So in that respect, we are not up to the performance of these guys. The big question is it performant enough to do the thing that you want to do? And when you look at the sort of games and projects that are currently being done in VR, some people run into performance limitations, which happens. And other people are finding that within the style that they're looking for and the capabilities that they have and the sort of game that they are making, Godot has more than enough performance. You know, for instance, for me, I'm building on, working on my space game. I have all, stop it. I have all, you know, my tutorials that I'm doing, and some have pretty complex scenes in there, which are running fine even on my old laptop, on my old 1080 GTX based laptop. Sorry, what am I saying? Is that 1080 or 1060? I can't remember what's in there actually. So yeah, it's all relative. It depends on what you want to do with it. But yeah, I would say that in our current state with Godot 3 OpenGL renderer, we're not up to the same performance level yet as an Unreal would be. But we're gaining on them. Especially with the new Vulkan renderer, I think we're getting closer and closer. And of course, you know, next month me starting full time on this will allow me to sink a lot more time in performance optimizations as well. So while I won't be working on that right away, I think we're, you know, we're going to be pretty much something to, you know, a force to be reckoned with, I gather. Anyway, let's go and have a look at whether we can make this work right now. All right, so this is gonna go crazy output-wise, but that's okay. All right, so we're definitely not getting an input at that point in time. Okay. All right. So it's not in our communication to Godot where it's going wrong. It's not that our code isn't being executed. We're actually not anywhere. Now I'm going to put this inside of the ndif for debug information. So there we go. Oh, maybe not that. Strange that it doesn't draw the lines all the way through. Alrighty. So let's go to our get action states. All right, so oh, it's not even coming back as active. Now let's see. It might not even be bound. I'll just go and output it over here then. Oh, yep. It's pointer. And that should actually be 0 and 1. Yeah, of course. Okay. Try that again. Actually, that now means that I no longer have to use the pointer notation. Oh boy. All right, let's see if I did it right. In this case, I'm just going to run instead of edit. Where's our... So yeah, we can still see that we're not getting any data back. So I'm guessing that our mapping isn't working the way that we thought it would work. Because we're not getting these. So how are we going to find out what we did wrong here? Because I bet you it is because we aren't defining this correctly. Although I would have assumed that it would have complained about it then. Created excellent. Runtime is obeying suggested bindings. The suggested binding path must refer to the parent of input values instead of the input values themselves, and the parent path must contain subpaths x and y. Must be bound x and y to the vector respectively in any other situation. No, it does sound like we're doing, and now that I read it again, it does sound like we have to get that path. What are we missing? Oh. That definitely would have had a problem, but seeing we're not getting valid values, that is not our problem right now. Dang it. What are we missing? I'm gonna fix that right now. X. The other thing, we're not getting an active state on this. Okay, for a given hand. Okay, is there a name difference that we're overlooking? Hold on, wait. No, that's a daydream. Bouncing. Touch. Space trigger. Thumbsticks X and Y. Input thumbstick X, Y. Input thumbstick X, Y. So they are definitely both the same inputs. Okay. Yeah, that's just that it's not tracking. It's fine. Couldn't see it at that point in time. Oh. We got a value at some point. Completely Bullock's value, but we did get a value at some point. That's interesting. All right. So, no interaction profile. Okay, so eventually we're going to the interaction profile controller. Interesting how we get those double. Now what I wonder about okay. Okay. So that's when it changes. Is there a way that we can see whether all the mappings work? That's the question. Okay. Is there a way we can check what the mappings is? Okay, so that's all the sync actions, but we do that. So that's just the ones that we just implemented. Excuse me. Okay, come on. There has to be a way that we can check whether our bindings are actually applied. I'm just giving a path object back. That's fine. So that's how we're applying it. That's not giving us any. Okay, so we're getting events here. Let's see if we have an event that tells us. Oops. Oh, that's a bit of a mess. You'd think that all the events would be together. Business loss, spending, session sales. Oh. That's not an event, okay. It's not really giving us much help. Define people planning not properly. I think it can do is by calling each interaction profile that the application has default bindings for. If bindings are provided for an appropriate interaction profile, the runtime may select one and input will begin to flow. Interaction profile selection changes must only happen. Can call current interaction profile during any learn what the active interaction profile are for a top level user path. The value if it changes, the runtime must send. Yeah, so that's the one that we're reacting to. Again. The bindings suggested by the system are only a hint to the runtime. Some runtimes may choose to use different device binding depending on user preferences, accessibility settings, or for any other reason. If the runtime is using the values provided by the suggested binding, it must make a best effort to convert the input value to the created action and apply certain rules. Okay. All right. Actually, that's interesting. I want to try something weird. Seeing that we're running here. Control settings. The binding UI. Okay. Can we edit it? Yeah, that's the one that we're using. Current boundary. Okay, so it hasn't applied any of the bindings. The actions have not been found. Jessic. Oh, it's mirror mode. Okay, that's fine. We're mirroring, so. Oh, why am I seeing my controllers? That's really, really weird. So we're still in the poses, but no. Anyway, I think when we look at this, I don't think the bindings actually have done anything. And we can actually see that we're now getting input on the left controller. So the right controller, and that might be because we've got mirror mode turned on here. Although that is in there. But it also means that our default bindings aren't working. Okay, that's really weird. Okay, let's try that one more time because it might have just... Okay, it's still working. Why is this not working? Not happy about something, that's for sure. Let's try this again. This is where I really need a flip up thing like the MR headsets. Run. Okay. No, it's still not working. Okay. So, well, obviously I want that output to be out of there, although we can now see. No, it's no longer doing my bindings. It's interesting. All right, so we're gonna make two changes. The first, I'm gonna comment this out to prevent all the spam. There we go. And the second thing that I want to do is duplicate this guy, move it over here so that we have both hands with a display. Right, let's go have a look if there's already a change, and then we're going back into a bindings window. Because now we're not getting anything, even though it did work for a little while. But let's go into our bindings again. So it actually didn't apply those bindings. Well, we still see that here. So I actually don't want that. Save as personal bindings. It's fine. Save it. Okay. Okay. No, not you. This one. Okay. Oh yeah, that doesn't work if it doesn't run anymore. That option doesn't actually do anything. That's so weird. It's supposed to show me my action bindings, but no luck. Now, it is possible that it just ignores that because, of course, this is our OpenXR situation. All right, so before we actually do anything more, we know that the buttons are supposed to work. So let's add those in as well. All right, so button IX. I'm not allowed to do that. Okay, it's fine. No. Oops. Okay. Um, that was code. There we go. So that's button 1 and button 2. All right. Yeah. All right, let's see if that works. Now, it could be on the wrong button, but we'll see quickly enough. All right. Okay, the buttons are working. Although this is BY. Yeah, BMI. Okay, that's fine. All right. So I guess this is going to become button. Okay. Oh. Yeah. It's not Rust where you can redefine things. All right. So we know that the buttons are working. That means that our binding logic are working. That means that the internal binding system for OpenVR is obviously disabled when you're using OpenXR. So it's purely looking at the OpenXR binding. So I would say that we're just not binding our action properly. Yep, we are going to go and create an editor for that. Well, the editor we're not going to create tonight. That's way over time. But again, you know, my point now was to sort of get some idea about how this worked and what the ingredients are, so we can start building something proper for this. Okay. I guess that's just for display stuff. I don't think they... I'm assuming that the naming here doesn't matter. Plus that it's created it, so it's not null. Input thumbstick, input thumbstick. Again, I'm assuming if I read that information correct, that does seem to be the way that we need to do this. All right, just to humor myself, just in case this is our problem. You never know. Just assuming that because we used those routes on another profile, or those paths, that it might not like that. Isn't it, this is pure gamble. Oh. Okay. It is there. All right. So those are working. Those are working. But the thumbsticks are still not working. Okay. right. So this is the other thing, of course. We're using the SteamVR OpenXR implementation right now. And I guess this is why I need to update this guy, because I haven't updated it for long enough. Because I tried to use the OpenXR interface for Oculus, but I'm pretty sure that I'm running a too old version for that, because I couldn't find it. Okay. And with that, the question is, are these correct? I wish there was a way to query which ones we have. Because for all I know, that one's wrong. Okay, could it have something to do with the action spaces? No, that's only for the pose. And that makes perfect sense, because the joystick is just a normal input. Here's the thing, right? You know, there has to be a way to validate that the bindings have worked. Okay. I'm going to go and log this and see if there's any events that we get. Oh, no, wrong place. Wrong place. Where are you? Here we are. Event type. That's the one. Oh, we have an unhandled event type. Okay. Oh, that's even a proper error. Okay, so we're grabbing every event type. Oops. We're definitely parsing every event type that we have in here. Okay. It just has the path. Okay, so if we had made a mistake, we would have gotten that. So we obviously set the right info in there. Active for a top level user path. Okay. Injection profile. So is that the one? Yeah, that was the one that we just looked at. Okay. What are we not seeing? Where are we? Type action state 2F. So that's correct. You got the correct type of buffer. Okay, so maybe okay. Oh, okay. That's how we make sure that we first get the left hand and then get the right hand. Okay. That makes sense. All right. Sorry, guys. I am a little bit stuck on this at the moment. So I'm sorry that I'm just staring at my screen for a little bit. That must be a little boring to watch. I really wish that this would give me more feedback about whether we are just not binding it right and therefore it's not getting it from the right path, or if we're just not getting data. So I still have a feeling that this might be different. Okay, let's see. Valve OpenXR binding. All right, let's take a really crazy gamble. Not you. I actually want to look at the original one. So here's called joystick. Just want to see what happens if we do this. Come to think of it. And there it's thumbstick. That's going to be interesting. All right. I think it's stuck again. Let's just restart it. Sometimes it just gets stuck when you run it a bunch of times. No. Still no luck. Okay, so I only have the trigger as a button, not as a value. Okay, I just want to go and put these back in. No, it's just not active. Yeah, Ryan. This is where we get to, you know, part of being a programmer. All right. So we are not getting active. We are not getting any last sync change. So it's definitely never even calling that. Okay. Now, one thing that I didn't look at. Well, again, it's just doing names, so we're not getting any feedback on whether we have the correct name or not. Okay, I'm just going to go and change that back to thumbstick. If we don't get this to work in the next 5 minutes, I am going to hook up my index and I'm going to see if there's any difference. Because again, we might just be applying the wrong names because we have no way of querying what possible inputs there are. Okay. So I'm not quite sure what's going on here, but let's just restart it. So that does not make any difference. Let's just double check if we are using the right name here. Yeah, thumbstick. Thumbstick. Okay. Using a thumbstick action. Giving it thumb up. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we don't have a mismatch there. And applying our actions. I was wondering why that was double, but yeah, no, that's right. Okay. It's gonna give a lot of spam. It is what it is. Because the thumbstick, this is the whole thing that it said over here, right? Where are you? It's just the bindings. So we're using an XR type vector 2. So we're getting both axes, both the X and Y axes at the same time. So it says the suggested binding path must refer to the parent of the input values instead of the input values themselves. So the parent is the thumbstick, and that parent must contain subpaths X and Y. So we can only use a path where then a X and a Y subpath exists, which is the thing with thumbstick. And then it will bind that X and Y subpath to the X and Y of the vector. So that's why we are doing thumbstick and not thumbstick X, because the fact that we are retrieving it as a vector will automatically get the X and Y subpaths of that path. So that part of it, I think, is working the way that it should. Hold on, I want to just disable that other bit of logic. It's a bit annoying that these things are parts, because we're getting way too much spam. Because the thing is, at some point I did see it getting output. Still not on that one. And also on that one. So I don't get it. It makes no sense at all. Type vector. And we're getting the vector 2 into there. And this is the other thing. It's not giving us an error on this. It's not saying like, hey, your mapping is wrong, or I don't know how to retrieve this, or anything like that. Okay. So, bear with me for a sec. Let's go and shut this down. Let's quit. Gonna quit this guy. All right. I'm just gonna grab my index. I'll be right back. Because now I want to see, is this a problem with the fact that I am using Octopus? In which case, it could still be that we're just giving it the wrong path. much cable on the thing. There we go. Where's my other controller? What did I do with that? Oh, it's all hidden over here. I hope there's still battery power in the controller. I haven't charged that for a while. I hope one day they get these things wireless properly. I know that you can get the TP cast thing, but I've heard mixed things about it. This cable is becoming a mess. Yeah. Yeah, that's one. It's two. And plug in the power. There we go. Okay. Let's see if I can do this without running over my cables. All right, go on. Do your thing. All right. You know what? See if we can trigger it to wake up. All right. It's not finding my base stations. There we go. Come on. Find my controller. There we are. Oh. So our code is working. It's the fact that we're using the Rift. So obviously. Oh, wow. Okay. Now, DS Notepad, I'm pressing up. Going to 9. Down. Minus. So up is positive Y. Down is negative Y. At least with OpenVR. And that's working. Okay. All right. So all this staring at the screen for half an hour to an hour is because I actually need to get this error handling. So this is complaining about the fact that I just put my headset down. That means that my lighthouse, because my lighthouses are in really bad position because of my green screen. My lighthouse over there isn't working. It's being blocked. So my tracking is dismal right now. But anyway, so that's why those errors are coming up, because the headset gets out of tracking range and it starts complaining about that. All right. So, so yeah, we were staring at the screen for over half an hour trying to figure out a bug that actually wasn't a bug. At least not as far as the code is concerned. This means that at least when using the Oculus Rift over SteamVR, where are you? This information is incorrect. That is not... Yeah, that is not the right path. Now, again, I'm seriously wondering whether... Because here's our input there. So on the Oculus Touch, it is left input joystick. Then again, we tried that and it didn't seem to work. So, yeah. So that's something that I need to find out. Now, I'm not going to do it tonight, but I will also update my my Oculus drivers to see if I can get OpenXR going on Oculus, and then use the Rift directly on Oculus instead of going through OpenVR, and test out the OpenXR system that Oculus has also implemented. And then I can see whether the naming convention holds up there. No, I don't have the Vive ones, but these guys do have a trackpad thing. But I can't imagine that they are the other way around, because they are the same way when you're using them over SteamVR. So pretty sure that if the joystick up is positive Y, then the thumbs the thumb thingy will be as well. And this is a crappy thumb thing anyway. It only goes up and down. It doesn't have a left and right. So not too happy about that. Anyway, bottom line is we've got a better idea about how this now works. And I'm going to start thinking of a actual mapping interface. But again, the thing that I really don't like, the thing that I really miss, is that we can't get a list of these. Now, I get the problem that if you are doing mappings for controllers that you don't actually have attached to your computer, or where you don't have the SDK for, not the runtime for, that there is no way to enumerate that list. But at the very least, I would expect that the current runtime running will be able to give you a list of possible paths for a given controller it supports. Because how else can you get a good interface for this, right? Because that's basically what the binding interface in SteamVR does do for us. So in SteamVR, it actually knows, or it actually reads those paths that it supports. And I wonder actually where it gets that from, because I can't imagine that is something where would that be? Because here are render models. Because that's the thing that happens with SteamVR, right? Every platform that it supports, it installs a driver for it. And then obviously, just like render models, it'll put the render models in here. So here we got our Quest models and stuff like that. So those get installed if you have the Oculus SDK. Those are just configuration bindings. Yeah, I wouldn't know where it would get that. No, some drivers. It's empty. Interesting. You've never really looked at where it would install those. Because for all I know, even that one's wrong. Although I set that up with the with their own interface, so again we tried it. I don't know, but that's definitely going to be a real problem for anybody who is going to be doing those mappings, unless we enumerate them, or at least have some default data in our plugin where we say, well, you know, these are all the inputs for these different controllers, that we can at least make the user interface more friendly. And obviously you'd want to have the ability to have new paths that you enter, because there might be enhancements or new versions of the controller, and you don't want to limit people to the ones that we know about. But at least we can pre-fill a whole bunch of things. Well, I could try it. You know, could just quickly rig it up and just map it to the to that guy. A big question is, what's it called? Well, that one would probably be accurately called here. So, yeah, next controller profile. So we do have the trackback X and Y. So I'm just going to fake it and say, I actually want to keep those. So I don't want to lose the thing. So let's just go and use that. Okay. Let's see if this wants to keep on working. Yep, looks good so far. All right, come on, come check. Whoa, some things. All right, I'm betting that it's outputting. Yeah, it's outputting a whole bunch of nonsense. Why? It's probably because my second controller isn't on. Is it? It's not happy about something, that's for sure. There we go. So yeah, my second controller wasn't on and it completely panicked. So that's definitely a thing that isn't working right in the plugin. Okay. Ooh, that's interesting. So this is all the way down, and that's up. But I can't get it all the way to 1. That's interesting. So yeah, Y positive, and down is Y negative. So the same orientation. It's just weird that it doesn't go all the way up to 1. I don't know why that is. And you can see that it does do left and right on that small little thing. It's really weird because it's just this little strip. Ow, ow, ow. Stuck. So yeah. So yeah, again, error spam the moment that we're not tracking. So that is something that I really want to start solving differently. Because instead of it erroring out like that, it should just disable the or treat the thing as in a as not tracking. So whoa. Luckily it's not high up. I don't have a good table here to put my headsets on, so I still have my Rift there. So I should have put that in the cupboard. All right, guys. That last bit was a bit more of a struggle than I'd like. It is 1:30 a.m. right now, so I am way past my bedtime. So yeah. All in all, I think we've got a good grasp on how the system works. So creating actions, creating the paths to the actual inputs that we want to have, and then creating profiles for the individual controllers. Now, obviously, Chris had already set most of this up, which is making our lives a lot easier because, you know, we can piggyback on that info, although it's all pretty straightforward. So the next step here is to actually put this in a structure. So instead of hard code it like we do over here, is to actually start building a config object in call it in the plugin, so that we can actually configure this and then build a nice UI. So the UI is probably just going to be Godot scenes and GDScript, which is really nice that we can add that in. But then they call into GNative objects to actually configure this stuff. And then we're going to have to find a nice way to figure out where we're going to save that or how we're going to make that part of the project settings. Yeah, again, David, I think the problem is, I never implemented this with thinking this would even be an issue, right? So I've always taken the inputs of these joysticks as they are. Now we've really only tested Steam VR here, because even though we're now using OpenXR, we're still using the Steam VR plugin. So it's still possible that that Oculus does it the other way around. I don't think so. I would be very surprised, to be honest. I guess we could hook up the Rift one more time and just check what it does in the normal Oculus SDK plugins. Then again, I think you tested it with the Quest, right? So not the WebXR version, but the normal environment. So I think that Y is up is pretty standard in this use case. Should we make it inverted in the plugin so that it is in line with the normal joypad interface? I don't know if it's worth it. I get that WebXR for some reason has flipped it around. I find that strange though. I wonder why WebXR did. I wonder why, especially when you look at the fact that when WebXR is talking directly to to the SDK, if you use A-Frame or whatever, it's talking directly to the SDKs of the different headsets. It would have gotten them the same, so it needs to be inverting whatever it's getting from the host, from the runtime. So they might have wanted to put it in line with controllers. I don't know. Again, for gamepads, I understand, right? When you look at your normal gamepad, you press up on a 2D game, you expect your character to go up, and in a 2D game, up is Y negative. Your screen is 0 at the top and 1 at the bottom, so going up is negative. So I get that has always been the default input for joysticks on a gamepad, or even probably from Atari days or older. Yeah, I guess that's possible. And again, Godot does the same, right? So if this is the gamepad that came with my original Oculus Rift, and if I would be using the Oculus Rift with Godot, I actually get this guy twice. I get it as a joystick recognized by the joystick system in Godot, and I get it recognized. I think I actually ignore it in the SDK, but if I would have also brought it forward as a XR controller, then on the XR controller it will be Y positive, and then on the joystick it will be Y negative. Which is also one of the reasons that I decided not to use this as an input, and that's the same with OpenXR, right? When you look at OpenXR, you can see that it actually allows you to bind to a gamepad. You can have a gamepad as an input. That will be like a third device. So if I attach this guy to my laptop, Godot would see it as a joystick because it just sees it as a direct input joystick. But then OpenXR, our OpenXR plugin, in theory, would be able to see this guy as well and react to it. So yeah, that's the thing. Now the other question that I need to think about is if we make a configurable action set here is what we really want. We kind of lose the ability to have the backwards compatibility layer because we wouldn't have anything hard-coded in here. So that's the other thing that I need to think about and see, okay, is that something that I'm still going to have, you know, a hard-coded action set to make the AR/VR controller work? Or am I just going to say for the OpenXR plugin, forget about the AR/VR controller for now until, you know, in Godot 4 we rewrite that stuff, and we're purely going to be using OpenXR pose, OpenXR inputs, etc. We shall see. I'm undecided there, or maybe I'll make a hybrid of it. I'm not sure. All right, guys. I think it is way too late for me. I hope this was interesting. Something very different from what I do normally. We're obviously not working on building a game today. We're looking at how OpenXR works. Now, obviously, for everybody who is interested in OpenVR, you know, we obviously went through the new action system a little bit just to explain it. Although in the end, now there's some examples in the demo for it. Yeah, waiting for Godot. Well, you know, it is still waiting for Godot for VR because I haven't really started on that. But that said, you know, it's actually one of the things that I'm thinking about doing a stream about as well. Is just playing around with the current Godot 4 version. You know, the pre-alpha version, so to speak. I haven't actually played around with it yet since the beginning of the year, but I really want to play around with all the automatic LOD stuff. So yeah, you can wait for it, or you can just download version. I don't know if everybody is aware of this, but Godot Master Hugo. Here we go. Hugo does nightly builds of Godot, so you can download the current master with all the bugs from his website, which is really cool. So this is updated every night. Oh, my eyes being a bit weird. So yeah, I don't know why Windows outdated macOS. I don't know why that's outdated. Anyway, so yeah, if you're tired of waiting for Godot 4, you can download it there, and if you don't want to compile it yourself, but be aware that there's still a lot of bugs in it. Now, I don't know actually at this point in time. Let's have a look. Will it find it this way? The project setting to control texture load. No, that's not what we want. Okay, it's probably gonna give. Well, let's have a look at the closed ones. Well, Mesh Optimizer is merged, so that's actually improvements on on the automatic LOD. Here you go. Implement automatic LOD. It's been merged. Ha! Sweet. Because I really want to play with that one. So yeah, here we go. Yeah, that's definitely something that I want to start playing around with, because I want to do some high-level detail stuff just to see how much I can push it. But yeah. All right. Thanks for joining, everybody. I think that's really where we're going to end it today. Interesting stream, I would say. I'll keep you guys posted on how I proceed with this. So thanks for watching, as always. I hope you'll join me next Friday, and till then, see you guys next time.